So let's get started learning Amazon S3. And we may already know what Amazon S3 is. I just want to give you a quick reminder, or at least remind you the options are going to be necessary to know when you want to pass the AWS Big Data exam. So first, let's just talk about buckets at a high level. We can store files or objects in things called buckets, and they're basically giant directories. Buckets must have a globally unique name, so when I create a bucket, I cannot name it like you named it, even though we have different accounts. Buckets will be defined at the region level, although in the UI they will appear globally. There's a naming convention for these, and there's no uppercase, no underscore. They must be between 3 and 63 characters long, and not an IP, and they must start with a lowercase letter or number. So overall, very basic. We'll be creating a bucket very, very shortly. Then what about the objects? Well, the objects are files, and they must have what's called a key. And the key represents the full path of that object. So here's an example. Here's my bucket name / myfile.txt. Or if it's a file that's nested within different folders, it looks like this. This is a full path to the file. So there's no concept of directories or folders within buckets, although it makes us think otherwise because we have slashes, but it's just a UI trick, okay? Right now, we just have long keys with very long names, and they can contain slashes. So the two above have the same level, but they're different keys. And one has like my folder one / another folder / myfile.txt. Okay, so then the object has a value, and the max size of an object is 5 terabytes. So if you do big data, you can think about what does that mean for your data. So max is 5 terabytes for your object. And if you upload more than 5 gigabytes, you must use multi-part upload. That's something you should know. But even if your file is say 100 megabytes, you will probably gain some advantage by using multi-part upload. So if it's more than 5 gigabytes, you must use it. And if it's more than 100 megabytes, you should use it, okay? Now, you have metadata on top of your objects. So it's a list of key value pairs, system or user metadata. And then you have tags. You can tag your buckets if you want to have security or lifecycle or whatever. Finally, your object can have a version ID, which is if versioning is enabled, all right?
So, how does S3 consistency work? Well, as of December 2020, now there is strong consistency on Amazon S3 for all operations. And this is something that was different from before. So just remember that now it's very simple. All operations are strongly consistent. What does that mean? Well, that means that after you write a new object, so after you do a successful write and you write a new object into Amazon S3, or after you overwrite or delete an existing object, okay? After you do any of these operations, anytime you do a read, okay, read after write, you're going to receive the object that was just written. And that used to be not the case, but now it is. And anytime you do a list, then you're going to also see that item into the list. So it's something new for Amazon S3 as of December 2020. So just remember that now Amazon S3 is strongly consistent. So anytime you do a write, then you do a read after, the read is going to give you the same results of what you just uploaded or what you just wrote. So this is perfect. And this is available to you at no additional cost without any performance impact.
So that's it. Let's just have a quick look at how S3 works now. So let's tap S3 and we are taken to the S3 UI. Now we're going to create a bucket, and that bucket, I'll just call it the bucket of Stefan Big Data. I'm sure this name will not be taken. And basically I choose a globally unique name for this. If I just choose Big Data, I'm pretty sure, this might work. So Big Data, create. No, the bucket name already exists. So yeah. So basically you cannot have a bucket name that someone already chose, and someone already chose the Big Data bucket name. So I'm going to choose the bucket of Stefan minus Big Data, and this will be globally unique, I'm pretty sure. Now region-wise, well, you can select the region you want your bucket to be into, usually something close to you. I'll choose US East Ohio for me. And then you click on next. You can configure options for your bucket. Could be versioning, could be server access logging, object level logging, etc. Default encryption. We'll be seeing encryption in this section as well, so don't worry too much. Right now we will not check anything. Click on next. Finally, there's some public access setting for this bucket. So these are enhanced security to make sure that when you put files in the bucket, they're not publicly accessible by default. We'll leave it as is. And then next, we can just review all the settings we have. We haven't modified everything, so we could have just clicked on create right away. Anyway, we'll create the bucket right now. And now our bucket is created. Excellent. So when you click on that bucket, you can basically upload files, and you can upload files by dragging and dropping there or click on add file. So let me click on add files, and I will choose online retail extract.csv. It's just a small file. that Frank will play with later. But this is just a CSV file that contains our retail data. And so we're uploading it onto S3, and here it is. Now it is onto S3. As you can see, now we could basically do a lot of analysis on it. Obviously, we're not there yet. We're just learning about how to store data, but we've been able to store a CSV file into S3, which is already something big. We could also have folders. For example, it could be store ID. So we could be like stores. I could actually, instead of doing store ID, I'll delete this. Here we go. So I could basically create a directory in S3, and this is how you would organize data. So you would have your stores, and then within your stores, maybe you would have all your different IDs. So you would have my store 1, which is my first store, and then within this store, maybe you would also have a date. So who knows, 10/22, 2018, just a random date, right? And who knows if that date is well formatted or whatever. You could have subfolders, you could do whatever you want. But in there, I could go ahead and upload my very same file. And so now we can start basically organizing some data within S3 to basically make sure that it is well organized. So I know that within my store, I will get all my stores. Within store 1, I will get all the dates of data, maybe because it's a daily extract that I'm going to put there. And I know that within each folder, I will find the extract for the day. So it's just a way of organizing data, but at least it shows you that you can have top level keys, which is quite a rare encounter for big data. Or most likely your data is going to be organized in different folders. So here I could have a store 2. And within each folder, you have more and more folders, basically to partition further down. And when the partitioning is done, then you can have finally your data in CSV format or other formats. So S3 support any format, right? It could be any file you could upload. It could be images, CSV files, binary files, whatever you want. That's, I think, really what matters. So hopefully you get an idea. Now, don't worry about how do I organize my S3 folders. This is something we'll see in depth, and this is something that when we do extracts going maybe from EMR or other technologies, the directory folder will be created for us. So that's it just for a quick S3 overview on the big data more side of things. I will see you in the next lecture. Okay, so let's discuss the different storage classes we have for Amazon S3. The first one is Amazon S3 Standard, general purpose. Then we have Amazon S3 Infrequent Access. Then we have Amazon S3 One Zone Infrequent Access. Then we have Glacier Instant Retrieval, Glacier Flexible Retrieval, Glacier Deep Archive, and then finally the Amazon S3 Intelligent Tiering. So we'll learn about all these classes in depth in this lecture, but you have to know them for the exam. Then when you create an object in Amazon S3, you can choose its class. You can also modify its storage class manually. Or, as we'll see as well, you can use Amazon S3 lifecycle configurations to move objects automatically between all these storage classes. So first, before we go into the classes, let's define the concept of durability and availability. So durability represents how many times an object is going to be lost by Amazon S3. And so Amazon S3 has a very high durability. It's called 11.9, so 99 point and then 9 times 9%. And that means that on average, if you store 10 million objects on Amazon S3, you can expect to lose a single object once every 10,000 years. So it's quite durable. And the durability is the same for all storage classes in Amazon S3. Availability represents how readily a service is. And so this depends on the storage class. For example, S3 Standard has a 99.99% availability. That means that about 53 minutes a year, the service is not going to be available. That means that you will get some errors when you deal with the service. So you need to take that into account when you develop your applications. Okay, so S3 Standard has 99.99 availability. It's going to be used for frequently accessed data. This is the kind of storage you use by default. And it has low latency and high throughput. It can sustain 2 concurrent facility failures on the side of AWS, and the use cases for it is going to be big data analytics, mobile and gaming application, as well as content distribution. Next, we have S3 Infrequent Access. So this is data that is going to be, as the name indicates, less frequently accessed, but requires rapid access when needed. It's going to be lower cost than S3 Standard, but you will have a cost on retrieval. So the S3 Standard IA is 99.9% availability, so a bit less available. And the use case for it is going to be disaster recovery and backups. And Amazon S3 One Zone Infrequent Access, One Zone IA, has high durability, okay, within a single AZ only. And the data is going to be lost if the AZ is somewhat destroyed. as well as the availability, it's even lower, so it's 99.5% availability. And so the use cases of S3 OneZone IA is to store secondary copies of backups of maybe on-premises data or data you can recreate. Next, we have the Glacier storage classes. So Glacier is, as the name indicates, very cold. So it's low-cost object storage meant for archiving and backup. And the pricing is that you're going to pay per the storage plus pay for a retrieval cost. And you have three classes of storage within Glacier. You have the Amazon S3 Glacier Instant Retrieval, and this gives you milliseconds retrieval, which is great, for example, for data that's accessed once a quarter. And the minimum storage duration is 90 days. So this is backup, but you need to access it within milliseconds. Then we have the Glacier Flexible Retrieval. It used to be called Amazon S3 Glacier, but then they renamed things as they added more tier. So the Amazon Glacier Flexible Retrieval has three flexibilities. So you have expedited, where you get the data back between 1 and 5 minutes. You have standard, to get the data back between 3 to 5 hours, or bulk, which is free, where you get the data back between 5 to 12 hours. And the minimum storage duration as well is 90 days. So here, instant means you retrieve the data instantly, and flexible means that you're willing to wait up to, for example, 12 hours to retrieve your data. And then we have Glacier Deep Archive, which is meant for long-term storage. So we have two tiers of retrieval as well. We have standard of 12 hours and bulk of 48 hours. So you may be ready to wait a lot of time to retrieve data, but it's going to give you the lowest cost, and as well, the minimum storage duration is 180 days. So as you know, that's a lot of storage classes, and there's one last called S3 Intelligent Tiering, which is going to allow you to move objects between access tiers based on usage patterns. And for this, you're going to incur a small monthly monitoring fee and auto tiering fee. And there are no retrieval charges in S3 Intelligent Tiering. So there is the frequent access tier, that's automatic, that's the default tier. Then we have the infrequent access tier for objects not accessed, for example, for 30 days. Then you have the archive instant access tier, automatic as well, for objects not accessed over 90 days. And then the archive access tier, that's optional, and you can configure it from 90 days to 700 plus days. And then you have the deep archive access tier, also optional, that you can configure for objects that haven't been accessed between 180 days to 700 plus days, okay? So S3 Intelligent Tiering is really to allow you to just sit back and relax while S3 moves objects for you. So if you compare all the storage classes, you don't need to remember these numbers, but it's just for you to make sense of what they are. So you get durability of 11 nines everywhere. Then the availability goes down the less zones you have, of course. It just shows you, like, for example, the minimum storage duration charge and so on. So take some time to look at this diagram on your own. You should understand it, but you should not remember it for sure. So if we look at some pricing, for example, in US East 1, so this is the kind of pricing you would have for all the storage classes. And again, you're not supposed to remember everything, but it's good for you to have a look at it on your own time just to make sure you understand, because if you understand what the classes' name are, then you should be able to make sense of these classes, okay? So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So let's create a new bucket in S3 and call it S3 Storage Classes Demo 2022. Okay, then I create into any kind of region, and I will go ahead and just create this bucket. So back in my bucket, I can go ahead and upload a object and click on Add Files. I will choose my coffee.jpg, and let's have a look at the options. So we can look at the properties of that object, and under storage class, I get the wide range of storage class that are for AWS objects. So we have S3 standard, okay, and we get the design for column, how many AZs we have, as well as some other columns such as the minimum storage duration, minimum billable object size, and monitoring and auto tiering fees. So let's have a look at all of them. So we have standard, which is the basic ones by default. Then we get intelligent tiering in case we don't know our data patterns, and therefore we want AWS to perform the data tiering for us. Standard IA, if we want data to be infrequently accessed, but still with low latency. One zone IA, which is that you can recreate this data and it's going to be stored in one AZ only, and therefore you can run the risk of losing the object if the AZ is destroyed. Then we have three Glacier levels. So we have Glacier Instant Retrieval, Glacier Flexible Retrieval, or Glacier Deep Archive, and they tell you exactly what are the conditions in here.
And finally, reduced redundancy, which is a deprecated type of storage tier, and therefore I did not describe it in the course. So what if we go with standard IA, for example, and create an object there? So we're going there, and then we're going to say upload back in our bucket. So now this object has the storage class standard IA as it is shown here. But what I can do is that I can also change the storage class if I wanted to. So I can go into properties and scroll down, and we can actually edit the storage class to do something different. So we can move it, for example, to one zone IA, in which case this object is going to be stored in one zone only. So let's save these changes. And now my object has successfully been edited, and therefore the object class has changed. So if we scroll down, now we are in one zone IA. And again, you could edit it and go, for example, for Glacier Instant Retrieval. And now it's going to be archived. Or you can go for intelligent tiering, and it could be automatically set to the right tier based on our patterns and so on. So as you can see, there's a lot of power using storage classes. And finally, I want to show you how we can automate moving these objects between the different storage classes. So let's go back into our buckets, and there under management, you can create lifecycle rules. And you can create a rule, and we'll call this one demo rule. And then you're going to say, hey, apply to all objects in the bucket. Yeah, sure. And then we can say, okay, move current versions between storage classes. And you're saying, hey, you go to standard IA after, for example, 30 days. And then you go to intelligent tiering after 60 days. And then you would go to Glacier flexible retrieval after 180 days, and so on. So you get some transitions, and in here you can review all the transitions you have done. So it is possible for you to automate moving objects between tiers, okay? So that's it. We've seen everything we need to know about storage classes. I hope you liked it, and I will see you in the next lecture.
So you can transition objects between storage classes as we've seen in the previous hands-on. So we can do it in what way? Well, there is a giant graph on the AWS website that describes how to do it. So it's pretty complicated, but as you can see from standard IA, you can go to intelligent tiering, one zone IA, and then Glacier, deep archive, and it just shows the possible transitions. As you can see from Glacier, you cannot go back to standard IA. You have to restore the objects and then copy that restored copy into IA if you wanted to. So for infrequently accessed objects, move them to standard IA. For archived objects that we don't need in real time, the general rule is to move them to Glacier or deep archive. And so moving all these objects around all these classes can be done manually, but it can also be done automatically using something called a lifecycle configuration. And configuring those is something you are expected to know going into the exam. So lifecycle rules, what are they? You can define transition actions, which are helpful when you want to transition your objects from one storage class to another. For example, you're saying move objects to standard IA class 60 days after creation, and then move to Glacier for archiving 6 months later. So fairly easy and fairly natural. Expiration actions, which is to delete an object after some time. So for example, your access log files, maybe you don't need them after another year. So after a year, you will say, hey, all my files that are over a year old, please delete them, please expire them. And it can also be used to delete old versions of a file. So if you have versioning enabled and you keep on overwriting a file and you know you won't need the previous versions after maybe 60 days, then you can configure an expiration action to expire objects, old versions of a file after 60 days. It can also be used to clean up incomplete multi-part uploads in case some parts are hanging around for 30 days and you know they will never be completed. Then you would set up an expiration action to remove these parts. And rules can be applied for a specific prefix. So if you have all your MP3 files within the MP3 quote-unquote folder or prefix, then you can set a lifecycle rule just for that specific prefix. So you can have many lifecycle rules based on many prefix on your bucket. That makes sense. And you can also have rules created for certain object tags. So if you want to have a rule that applies just to the objects that are tagged department finance, then you can do so. So the exam will ask you some scenario questions, and here is one, and you need to think about it with me. So your application on EC2 creates images thumbnails after profile photos are uploaded to Amazon S3. And these thumbnails can be easily recreated, and you only need to be kept for 45 days. The source images should be able to be immediately retrieved for these 45 days, and afterwards, the user can wait up to 6 hours. How would you design this solution? So I'll let you think for a second. Please pause the video and then we'll get to the solution. So the S3 source images can be on the standard class, and you can set up a lifecycle configuration to transition them to Glacier after 45 days. Why? Because they need to be archived afterwards, and we can wait up to 6 hours to retrieve them. And then for the thumbnails, they can be one zone IA. Why? Because we can recreate them, okay? And we can also set up a lifecycle configuration to expire them or delete them after 45 days. So that makes sense, right? We don't need the thumbnails after 45 days, so let's just delete them. Let's move the source image to Glacier, and the thumbnails can be on one zone IA because it's going to be cheaper, and in case we lose an entire AZ in AWS, we can easily, from the source image, recreate all the thumbnails. So this is going to be providing you the most cost-effective rules for your S3 buckets. Now, a second scenario, there's a rule in your company that states that you should be able to recover your deleted S3 objects immediately for 15 days, although this may happen rarely. After this time and up to 1 year, deleted objects should be recoverable within 48 hours. So how would you design this to make it cost effective? Okay, let's do it. So you need to enable S3 versioning, right? Because we want to delete files, but we want to be able to recover them. And so with S3 versioning, we're going to have object versions, and the deleted objects are going to be hidden by delete marker, and they can be easily recovered. But we're going to have non-current versions, basically the objects versions from before. And so these non-current versions, we want to transition them into S3 IA, because it's very unlikely that these old object versions are going to be accessed. But if they are accessed, then you need to make sure to recover them immediately. And then afterwards, after these 15 days of grace period to recover these non-current versions, you can transition them into deep archive, such as for 365 days they can be archived, and they would be recoverable within 48 hours. Why don't we use just Glacier? Well, because Glacier will cost us a little bit more money, because we have a timeline of 48 hours, and so we can use all the tiers all the way up to deep archive to retrieve our file and get even more savings. So this is the kind of exam questions you would get, and it's really important for you to understand exactly what the question is asking and what storage class is corresponding the best to it, and what lifecycle rule can also correspond the best to it. So let's go into the hands-on just to set up a lifecycle rule.
Okay, so now let's have a look at lifecycle rules. For this, I'm going to go into management and I can define a lifecycle rule. So let me create one. I will call this one demo rule, and we can either apply it to a specific scope within our bucket or all the objects. I will apply to all the objects just for simplicity's sake in this video. So we have 5 different kinds of lifecycle rule actions. We can transition current versions of objects between storage classes or previous versions. So what do we mean by current and previous? Well, for current, we mean the object that is the most recent if we have enabled versioning. And for previous, we mean all the other versions of an object if we have enabled versioning. Then we can expire current versions of objects, permanently delete previous version of objects, and finally delete expired delete markers or incomplete multi-part uploads. So lots of different options. But let's just do this one. We're going to transition current versions of objects between storage classes. And we can say we can transition objects into the standard IA storage class after 30 days. Then we can move it into intelligent tiering after 70 days. And then move it into maybe Glacier after 180 days and Glacier Deep Archive after, let's say, 365 days. Okay. And there is probably, because I'm not doing my cost correctly, I get a small warning. If you transition small objects into Glacier or Glacier Deep Archive, this will increase cost. So obviously, if you do transition objects there, make sure they're big enough. Okay, great. So next, I can also expire current versions of objects. So we're saying, okay, after an object is created, maybe after 700 days, then please delete it. And we can also add a previous version transition just for fun. And we can say it, move it into Glacier after 60 days, because if it's a previous version, maybe we don't want to access it. We don't plan on accessing it. Okay, so I acknowledge this as well. And so we can look at the timeline summary. And so for current version actions, day 0, the objects are uploaded. Day 30, they are transitioned automatically into standard IA. Day 70 into intelligent tiering. Day 180 into Glacier. And finally, 365 Glacier Deep Archive, day 700, they will expire. And then for previous version actions, day 0, they become non-current, and day 60, they are transitioned into Glacier. Just, a simple, fun lifecycle rule to set up. But this shows you the whole power of lifecycle rules. You can set up multiple ones per bucket on different filters with different rules, and this allows you to really optimize your costs in AWS for Amazon S3. So I hope you liked it, and I will see you in the next lecture.
So now let's talk about Amazon S3 versioning. So your files in Amazon S3 can be versioned, but it has to be enabled first at the bucket level. So we'll do this in the hands-on. So that means that if you re-upload a file version with the same key, then it will override it, but it won't override it. Actually, it will create a new version of that file. So instead of overriding the file that already exists, it will create a new file version, and I'm simplifying it here, but it will be version 1, then version 2, then version 3, etc., etc. So it is best practice to version your buckets in Amazon S3 in order to be able to have all the file versions for a while, because you can get protected against unintended deletes because you're able to restore a previous version. And also you can easily roll back to any previous versions you wanted. So you need to know a few things though. Any files that is not versioned prior to enabling versioning will have the version null. And if you suspend versioning in your bucket, it does not delete the previous versions. It will just make sure that the future files do not have a version assigned to it. So let's go in the hands-on and see how that works.
So next, let's explore versioning in our S3 buckets. So for now, we just uploaded a coffee.jpg, and we didn't enable versioning when we created the buckets. But let's go into the Properties tab, and the first setting into the Properties tab is called Bucket Versioning. So let's edit it and move bucket versioning from being suspended to being enabled. I will click on Save Changes, and here we go. Our bucket is now enabled for versioning. So let's close this and go back to our objects. Great. So this is our first object, but now that we have enabled versioning, we have a new setting here called List Versions. This toggle right here, if I click on it, will add a column into the view of Amazon S3, which shows me the version ID. And it turns out that for coffee.jpg, the version ID is null. That means that we have uploaded this object before we enabled versioning onto our bucket, and therefore it will not have a version ID, hence the term null. But let's try to upload a new file, and this time we're going to upload the beach picture, so beach.jpg. I will scroll down and upload. Now the file has been uploaded. Let's go back to our bucket and list the versions. Now we can find that the beach.jpg has a version that is a very long string. And so this makes sense. As we have uploaded a version of the file after enabling bucket versioning, it's going to be assigned a version ID. Okay, what about if we upload the beach.jpg file again? So let's upload beach.jpg and see what happens. Okay, back in here, I still have two objects, but if I list my versions, now we can see that beach.jpg has two version IDs. This one is the one we uploaded from before, and this one is the new version ID we just uploaded right now. So as we can see, thanks to versioning, every time we re-upload a file, it will keep all its previous versions as well as the new version and assign a different version ID every single time. So this is cool. Now, what happens if we upload another time the coffee.jpg file? So let's try it out. We'll upload coffee.jpg. Upload. Great. Back in here, list versions. We can see that coffee.jpg has two versions. The first version that we just uploaded has a long version ID, and the one from before has the version ID null. Okay, this is great. Now let's try to unlist the object version. So we just have these two files right here, and let's try to delete a file. So for example, let's take the beach.jpg and let's try to delete it. So I'll click on delete. And as we can see, we get an information saying deleting the specified objects adds delete markers to them. So we're actually not deleting the file itself. We're adding a delete marker. Let's see what that means. So let's confirm we want to delete beach.jpg and press delete. Okay. So this is done. The object has been successfully deleted. Let's exit this, scroll down, and yes, it seems that my beach.jpg has been deleted. But actually, if I click on list versions, this toggle again, well, we can see that beach.jpg is still here. But now, on top of the two previous versions we have uploaded, we have a delete marker. And this delete marker has its own version ID of size 0 bytes and is saying to AWS, make it seem like this file is gone. But actually, it's not gone. It just has a delete marker. And so how can I restore a file? Well, I can just take this and delete the delete marker. Now, deleting a delete marker or deleting a specific version ID is called a permanent delete. So if I take, for example, these two files right here, these two versions, the delete marker and the previous version, because I want to delete two at once, I click on delete. Now, instead of just saying delete, it says you need to permanently delete because I'm deleting specific version ID. So it says a destructive operation. Before it added a delete marker, but now we're actually deleting the objects for good. So this cannot be undone. I'll click on delete objects and my objects have been deleted. Going back into my bucket one more time. What do we see? We see my beach and my coffee.jpegs are back. And if I list versions, I only have one version for my beach.jpg, which makes sense. This is exactly in line with the operation we just did. Okay. And so this allows us to roll back a previous version and restore a previous version thanks to the versioning. Okay. And this is quite cool because, well, if someone goes and deletes a file and we have enabled versioning, as long as they don't delete a specific object version, we have prevented against unintended deletes. And finally, for bucket versioning, you could go and disable it. It says not suspend it. So if you do suspend it, this is going to keep all the previous versions that you had from before, but for the new objects, they will have a version object, a version ID of null, and it will replace all the existing previous versions. Okay. Now I'm going to keep bucket versioning on because I need it for the rest of my demos. So that's it for this part. I hope you liked it, and I will see you in the next lecture. Now let's talk about S3 replication. And I say CRR and SRR because it means cross-region replication and same region replication. And I will explain to you this in a second. So you have an S3 bucket, and say that bucket is in EU West 1. And you want to replicate all the bucket content continuously into another region, US East 1. And you would do so, for example, because you want to save data in another region in case a disaster hits EU West 1. So you want asynchronous replication to happen behind the scenes. For this, you must enable versioning in source and destination buckets. And then you have either cross-region replication, that means that you go from different regions, in this example, EU West 1 to US East 1, and then same region replication, SRR, to go from the same region, so from EU West 1 to EU West 1. The buckets can also be in different AWS accounts, and the copying is asynchronous, so it will happen behind the scenes. You must give proper IAM permissions to S3, of course, to do the replication. And so the use cases of CRR are to do compliance, lower latency access, or replication across accounts. And SRR are going to be more around log aggregation across multiple accounts, live replication between production and test accounts, or disaster recovery. Now, some notes about S3 replication. When you enable S3 replication, only the new objects in your bucket are going to be replicated from then on. But if you want to replicate your existing objects, you have a feature called S3 batch replication, and it will replicate the existing objects as well as any objects that have failed the S3 replication mechanism. If you have a delete operation in your S3 bucket, then you can replicate the delete markers from source to the target bucket, and this is an optional setting. And if you have a deletion for a specific version ID, they're not replicated to avoid malicious deletes and for someone to delete data permanently in your buckets. And finally, there is no chaining of replication. So if bucket 1 has replication into bucket 2 and bucket 2 has replication into bucket 3, then the objects of bucket 1 are not going to be replicated to bucket 3. Okay, that's it for S3 replication. I hope you liked it, and I will see you in the next lecture. Okay, so let's have a play with S3 replication. So I'm going to create a first bucket, so demo Stéphane origin 2020 in EU West 1. And I'm going to enable bucket versioning because for replication, you need to enable bucket versioning on both the source and the target buckets. So I will create this bucket. And so this is my first bucket created. It's demo Stefan origin 2020, and it was an EU West one. But I'm also going to create a second bucket called demo Stefan replica 2020. And this time I'm going to choose something like in the US, so US East 1, for example, to replicate my data from Europe into the US. Maybe it is a disaster recovery strategy of yours. Okay, so I will scroll down, I will enable bucket versioning again, and click on Create Buckets. Okay, so both my buckets have been created, so my origin buckets and my replica buckets. And let's open them in new tabs. What I want to do is start uploading one object into my demo Stefan origin 2020. So I will upload yet again the coffee.jpg file and upload it. Here we go. And so right now, as we can see, it is in my demo origin bucket, but obviously we haven't configured anything, so it is not yet in my demo replica buckets. Okay, so for this now, I want to set up replication. So you need to go into management, and under management, there is replication rules. So we can create a replication rule here, and I'll just call it demo rule. And the rule is enabled. And what we do is that we can limit this rule to a specific scope within the bucket, so a subset of objects, or we can specify that this rule applies to all objects in the bucket. So it's up to you, but right now we want to keep this simple. Let's apply it to all objects in the bucket. Next, we need to choose a destination. So it could be a bucket in this account or in another account. Let's choose a bucket in this account. We'll browse S3 and find the demo replica buckets. So we'll choose this. And as we can see, the destination region is US East, Northern Virginia, US East 1. And so this is cross-region replication. But if the destination region was the same, it would be a same region replication for your replication settings. Okay. Finally, you need an IAM role to perform this action. And so we can just ask Amazon S3 to create this role for us, which is very nice. In terms of advanced settings, I'm just not going to check anything. We just want to demonstrate the capability right now. So let's save this. Oh, and one thing I want to show you, sorry. The delete marker replication right now is disabled, so delete markers are not replicated. But if you enabled it, delete markers would be replicated, and I will demonstrate this in a second. But right now, I will leave this as delete marker replication off. Okay, I will save this. And now my replication rule has been created and correctly configured. So what you would expect is that if we go into the origin bucket, we see one object, coffee.jpg. And if we go into the replica bucket and refresh, well, we'll still see 0 objects. So it turns out that as soon as you enable replication, it will not replicate old objects for you, previous objects. It will only replicate newer objects. So how do we fix this? Well, we can upload the coffee.jpg file again. So let's upload coffee.jpg and click on upload. Now this has uploaded the coffee.jpg file right here again in my bucket. So if I list versions now, I have 2. And you can see we have a new version ID of Q, D, D, RH, whatever. Now if I go into my replica bucket and refresh, within a few seconds, I should be seeing this object popping up. And here we go. My object has now appeared. And we can look at the fact that the version ID of this coffee.jpg is the exact same. So QDQRH is the exact same as the version ID I have on my origin bucket. So the object is replicated, including the object version ID. And if I upload, for example, well, a beach.jpg, it is obvious that it is also going to be replicated. So hopefully this makes sense. Now let's look about deletes. So if I take my coffee.jpg and delete it, I'm going to create a delete marker and press and click on delete. So this delete marker that is created is not going to be replicated. So let's prove it to ourselves. So right now we only have the beach.jpg in here in the origin bucket. And if I refresh here, I have the beach and the coffee.jpg. So the delete marker did not get passed on to the replica bucket. And we saw it from before. This was just a setting in the replication rule. So if we specify, we could also tell Amazon S3 to replicate these delete markers, but this is something you have to opt in by default. And finally, if I list my versions and say I wanted to delete a very specific version of my file. So let's say I delete all these files right here, and I will permanently delete them because I'm deleting specific version IDs in my buckets. These deletes are not going to be replicated. So again, replication rules do not replicate deletes and there's no way to replicate and delete actually between two buckets right now. So this is something good to know, and definitely a behavior you should be aware of at your exam, okay? And that's it for replication rules. Obviously, you can set up different replication rules in your bucket based on different prefixes and filters, and you can edit the rule if you wanted to. For example, if you wanted to scroll down and delete marker replication as well to enable it. But for now, we won't do it. We saw the basics of replications, and that should be enough for the exam. I hope you liked it, and I will see you in the next lecture.
So we have to talk about the S3 baseline performance. So by default, Amazon S3 automatically scales to a very, very high number of requests and has very, very low latency between 100 and 200 milliseconds to get the first byte out of S3. So this is quite fast. And in terms of how many requests per second you can get 3,500 put, copy, post, delete per second per prefix and 5,500 get head requests per second per prefix in the buckets. So this is something you can get on the website, and I think it's not very clear, so I'll explain to you what per second per prefix means. But what that means overall is that it's really, really high performance. And there's no limits to the number of prefixes in your bucket. So let's take an example of 4 objects named file, and let's analyze the prefix for that object. The first one is in your bucket, in folder 1, subfolder 1 / file. In this case, the prefix is going to be anything between the bucket and the file. So in this case, it is /folder 1 / sub 1. So that means that for this file, in this prefix, you can get 3,500 puts and 5,500 gets per second. Now, if we have another folder, 1 and then sub 2, the prefix is anything between bucket and file, so /folder 1 / sub 2. And so we get also 3,500 puts and 5,500 gets for that one prefix. And so on. So if I have 1 and 2, we have different prefixes. And so it's easy now to understand what a prefix is. And so it's easy to understand the rule of 3,500 puts and 5,500 gets per second per prefix in a bucket. So that means that if you spread reads across all the 4 prefixes above evenly, you can achieve 22,000 requests per second for head and gets. So that's perfect. Next, let's talk about KMS as a limitation to S3 performance. So if you have KMS encryption on your objects using SSE KMS, then you may be impacted by the KMS limits. When you upload a file, it will call S3 on your behalf, the generate data key KMS API, and when you download a file from S3 using SSE KMS, S3 itself will call the decrypt KMS API. And so these 2 requests will count towards the KMS quota. So let's have an example. Our users connect to your S3 bucket. They want to upload or download a file using SSE KMS encryption. And so S3 bucket will perform an API call, either generate data key or decrypt, to a KMS key and get the result from it. And so by default, KMS has a quota of number of requests per second. And based on the region you're in, it could be 5,500 per second, 10,000 per second, or 30,000 per second request.
And you can request a quota increase using the service quota console if you need to go over that limit.
So what this means is that if you have more than 10,000 requests per second in a specific region that only supports 5,500 requests per second for KMS, then you will be throttled. So you need to ensure that KMS doesn't block your performance on S3. Now, these quotas are pretty big for normal usage, but still good to know if you have many, many files and a high usage of your S3 bucket. Now let's talk about S3 performance, how we can optimize it. The first one is multi-part upload. So it is recommended to use multi-part upload for files that are over 100 megabytes, and it must be used for files that are over 5 gigabytes. And what multi-part upload does is that it parallelizes uploads, and that will help us speed up the transfers to maximize the bandwidth. So as a diagram, it always makes more sense. So we have a big file, and we want to upload that file into Amazon S3. We will divide it in parts, so smaller chunks of that files, and each of these parts will be uploaded in parallel to Amazon S3. In Amazon S3, once all the parts have been uploaded, it's smart enough to put them together back into the big file. Okay, very important. Now we have S3 transfer acceleration,
which is for upload and download.
And it is to increase the transfer speed by transferring a file to an AWS edge location, which will forward then the data to the S3 bucket in the target region. So edge locations, they're more than regions. There are about over 200 edge locations today, and it's growing. And let me show you in the graph what that means. And that transfer acceleration is compatible with multi-part upload. So let's have a look. We have a file in the United States of America, and we want to upload it to an S3 bucket in Australia. So what this will do is that we will upload that file through an edge location in the United States, which will be very, very quick, and that will be using the public internet. And then from that edge location to the Amazon S3 bucket in Australia, the edge location will transfer it over the fast private AWS network. So this is called transfer acceleration because we minimize the amount of public internet that we go through, and we maximize the amount of private AWS network that we go through. So transfer acceleration is a great way to speed up transfers. Okay, now how about getting files? How about reading a file in the most efficient way? We have something called an S3 byte range fetches. And so it is to parallelize gets by getting specific byte ranges for your files. So it's also, in case you have a failure to get a specific byte range, then you can retry a smaller byte range and you have better resilience in case of failures. So it can be used to speed up downloads this time. So let's say I have a file in S3, it's really, really big, and this is the file. Maybe we want to request the first part, which is the first few bytes of the file, then the second part, and then the nth part. So we request all these parts as specific byte range fetches. It's what it's called byte range because we only request a specific range of the file. And all these requests can be made in parallel. So the idea is that we can parallelize the gets and speed up the downloads. The second use case is to only retrieve a partial amount of the file. For example, if you know that the first 50 bytes of the file in S3 are a header and give you some information about the file, then you can just issue a header request, a byte range request for the headers using the first, say, 50 bytes, and you will get that information very quickly. All right, so that's it for S3 performance. We've seen how to speed up uploads, downloads, we've seen the baseline performance, and we've seen the KMS limits. So make sure you know those into going into the exam, and I will see you in the next lecture. Okay, so now let's talk about Amazon S3 encryption for your objects. The idea is that you upload objects onto Amazon S3, and these are servers of AWS. And so you may want to make sure that these objects are not accessible. For example, if someone gets into the Amazon servers, or you want to make sure you adhere to some security standards set up by your company. So as such, Amazon gives you 4 methods to encrypt objects in Amazon S3. The first one is called SSE S3. This is to encrypt S3 objects using keys handled and managed by AWS. The second one is SSE KMS, to leverage AWS Key Management Service to manage your encryption keys. The third one is SSEC, when you manage your own encryption keys. And finally, client-side encryption. Now we're going to do a deep dive on all of those, so don't worry. And it's important to understand which ones are adapted to which situation for the exam, because the exam will definitely ask you questions to choose the right level of encryption based on the scenario. So let's do a deep dive first on SSE S3. This is an encryption where the keys used to encrypt the data are handled and managed by Amazon S3. The object is going to be encrypted server-side. SSE means server-side encryption. And the type of encryption is AES 256, which is an algorithm. So for this, to upload an object and set the SSE S3 encryption, you must set a header called XAMZ server-side encryption AES 256. XAMZ stands for X Amazon. So X Amazon server-side encryption AES 256. And this is how you remember the name of the header. So let's have a look. We have an object and it is unencrypted. We have it right now. And we want to upload it into Amazon S3 and perform some SSE S3 encryption. So for this, we're going to upload the object onto Amazon S3. You can use the HTTP protocol or the HTTPS protocol, and you can add the header that we said, the XAMZ server-side encryption AES 256. And then Amazon S3, thanks to this header, knows that it should apply its own S3 managed data key. And using the S3 managed data key and the object, some encryption will happen and the object will be stored encrypted into your Amazon S3 bucket. Very simple. But here in this instance, the data key is entirely owned and managed by Amazon S3. Next, SSE KMS. So we haven't seen what KMS is right now. We'll see this pretty much towards the end of this course on the security side, but KMS is Key Management Service, which is an encryption service for you. So SSE KMS is when you have your encryption keys that are handled and managed by the KMS service. Why would you use KMS over SSE S3? Well, it gives you control over who has access to what keys and also gives you an audit trail. Each object is going to be again encrypted server side. And for this to work, we must set the header X Amazon server side encryption to be of value AWS KMS. So the idea is exactly the same because it is server side encryption. We have the object, we upload it using HTTPS and the header. And then using this header, Amazon S3 knows to apply the KMS customer master key you have defined on top of it. And using this customer master key, so the key you've defined and your object, there's some encryption that will happen, and the file will be stored in your S3 bucket under the SSE KMS encryption scheme. Next, we have SSE-C, that stands for server-side encryption, using the keys that you provide yourself outside of AWS. So in this case, Amazon S3 does not store the encryption key you provide, so it will absolutely have to use it because it needs to do encryption, but then that key will be discarded. For this, to transmit the data into AWS, you must use HTTPS because you're going to send a secret to AWS, and so you must have encryption in transit. Encryption key must be provided in the HTTP headers for every HTTP request made because it's going to be discarded every single time. So we have the object and we want to have it encrypted in Amazon S3, but we want to provide ourselves the client-side data key to perform the encryption. So we send both these things over HTTPS, so it's an encrypted connection between you, the client, and Amazon S3, and the data key is in the header. So therefore, Amazon S3 receives the exact same object and the client provided data key. And then again, it is server-side encryption. So Amazon S3 will perform the encryption using these two things and store the encrypted object into your S3 buckets. If you wanted to retrieve that file from Amazon S3 using SSE-C, you would need to provide as well the same client-side data key that was used. So it requires a lot more management on your end because you manage the data keys, and Amazon or AWS in general does not know which data keys you have used. So it's a bit more involved. Okay, and then finally, client-side encryption. So it is when the client, so you encrypt the object before uploading it into Amazon S3. Some client libraries can help you do this. For example, the Amazon S3 encryption client is a way to perform that client-side encryption. And as I said, clients must encrypt the data before sending it to S3. And then in case you receive data that is encrypted using client-side encryption, also CSE, then you are solely responsible for decrypting the data yourself as well. So you need to make sure you have the right key available. So as I said, in client-side encryption, the customer manages entirely the keys and the encryption cycle. So let's have an example. Amazon S3 this time is just a bucket where it's not doing any encryption for us because it is client-side encryption, not server-side encryption. And so in the client, we'll use a encryption SDK, for example, the S3 encryption SDK, will provide the object and our client-side data key. The encryption will happen client-side, so the object is going to be fully encrypted on the client side, and then we are going to just upload that already encrypted object into Amazon S3. Okay, so that's the 4 types of encryption, so hopefully that makes sense. And I've been mentioning encryption in transit in this lecture, now I'll make it very clear what it is. That's around SSL and TLS connections. So Amazon S3 is an HTTP service, and it exposes an HTTP endpoint that is not encrypted, and it exposes an HTTPS endpoint, which is encrypted and provides what's called encryption in flight, which relies on SSL and TLS certificates. So you're free to use the endpoints you want, but if you use the console, for example, you would be using HTTPS, and most clients would, by the way, use HTTPS endpoint by default. And so if you're using HTTPS, that means that the data transfer between your client and Amazon S3 is going to be fully encrypted, and that's what's called encryption in transit. And one thing to know is that in case you're using SSE-C, so server-side encryption, and the key is provided by your client, then HTTPS is mandatory. Also, so as I said, finally, encryption in flight is also called SSL TLS because it uses SSL and TLS certificates. So let's go into the hands-on to see how encryption works now. Now let's look at encryption settings. So we'll go into the coffee.jpg file, and I'm going to scroll down, and let's have a look at the encryption setting. So as we can see, for server-side encryption setting, right now there is default encryption disabled and server-side encryption none. So our object is not encrypted. Now we could edit it and encrypt it in place, but I want to show you how it's done as well when we upload a file. So let's go ahead and upload a file. I will add a file, and I will add again the coffee.jpg file. Now we'll scroll down, and I will look at additional options for encryption. So let me scroll down. We are getting into the server-side encryption settings. I will click on enable, and here we have different kind of options. So obviously we disable it, and this is no server-side encryption, which was a default from before, or we can enable it. So the first encryption type we've seen and learned from is SSE S3. In this case, we are using an Amazon S3 key, and this is an encryption key that Amazon S3 will create, manage, and use for us. So fairly easy. This is one we could do, and we could just go ahead and create that file, for example, with Amazon S3 key. So let's scroll down, upload it, and that's it. We have uploaded a file with encryption of SSE S3. Now let's do it again, but for the beach.jpg. So let's add a file and go for beach.jpg. And I'm going to expand the additional upload options. Scroll down, enable server-side encryption. And the second option is AWS KMS key. So SSE KMS. In that case, as we've seen, we still have an encryption key, but this time that encryption key is protected by the KMS service. And here we have a couple of options. We could use an AWS managed key, which is AWS/S3, and this would be an easy option. Or you can choose from your own KMS master keys if you wanted to create your own key, which we'll not do right now. Or if the key is in another account, we could enter the KMS master key ARN, Amazon resource name, manually in here. But to keep things simple, we're going to use an AWS managed key, AWS S3. And this is going to make sure that the key encryption happens by doing API calls into the KMS service, okay? So let's upload this file again. Okay. Now, if we exit this, let's have a look at what we have. So we have 5 object versions. So we have different coffee.jpg, we have different beach.jpg. And so we could look at specific object versions in particular. So if we look at the beach.jpg we just had and the one from before, let's have a look at what the encryption says. So this is the one I just uploaded. And if we look at the encryption setting, it's encrypted with AWS KMS master key, so SSE KMS. And if I look at the beach.jpg we had from before, when we first uploaded that file, if I scroll down, as we can see, server-side encryption is none. So what this means is that the encryption setting is just for a specific file and its specific version ID. But this will make sense. So we can upload these files manually and specify the encryption setting for each file. Or if we wanted to, we could, for example, go into properties and specify a default encryption mechanism for the buckets. So how do we do it? Well, for example, let's edit this default encryption setting. So here we go, I will edit it. And we will enable server-side encryption by default. And let's say we want by default every single object to be uploaded with the Amazon S3 key. So we'll use this, save the changes. And now let's try to upload a file without any encryption. So let's have a look. So we'll go to objects, upload it, and I'm going to upload a coffee.jpg file, but I'm not specifying any encryption. But as we can see, the default encryption is enabled, okay? But if I go into additional upload options, I'm saying encryption to use the default encryption bucket settings. And so as you can expect, if I upload this file, what is going to happen? Well, let's have a look. I'm going to click on this file ID right here and look at the kind of server-side encryption setting it has. And yes, it has an Amazon S3 master key. So the default encryption setting
worked properly. And so lastly, you may be asking me, hey Stefan, so you taught us about more settings, to encrypt files. So why don't we see them? So let's have a look. If I go into the options and look at overriding, as we can see, we have Amazon S3 key, so SSE S3, or SSE KMS. Another one we have learned is SSEC, and we can only do this through the CLI because we have to pass in an encryption key into AWS securely to encrypt that object. So this is not something that is developed to be done through the console at this time, so it's not accessible to us. So the SSEC option is not going to be shown. And the last option I showed you was called client-side encryption. And client-side encryption means that we need to encrypt objects client-side, so on our own computers, before uploading to Amazon S3. And so Amazon S3 doesn't really care if it's encrypted or not. It will just take all the bytes anyway. And so this is why this option does not show anything here as well. So that makes sense. This is why we can only see SSE S3 and SSE KMS. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture.
Okay, so now let's talk about Amazon S3 security. So it's very complex, but first you have user-based security. So our IAM users have IAM policies, and they authorize which API calls should be allowed. And if our user is authorized through IAM policy how to access our Amazon S3 bucket, then it's going to be able to do it. Then we have resource-based security, and this is the infamous S3 bucket policies. They're bucket-wide rules that we can set in the S3 console, and what they do is that they will say what principals can and cannot do on our S3 buckets. And this enables us to do cross-account access to our S3 buckets. We'll do in the hands-on a very deep dive on S3 bucket policies. Then we have object ACL, which is finer grain, where we set at the object level the access rule. And then finally, bucket ACL, even less common, and these two don't really come up at the exam. Okay, note, an IAM principal, so it could be a user, a role, can access an S3 object if the IAM permissions allow it. So that means that you have an IAM policy attached to that principal that allows access to your S3 buckets, or if the resource policy, so usually your S3 bucket policy, allows it. And you need to make sure there is no explicit deny. So if your user through IAM is allowed to access your S3 buckets, but your bucket policy is explicitly denying your user to access it, then you will not be able to access it, okay? Okay, so now let's do a deep dive on S3 bucket policies. They're JSON-based policies, so JSON is a notation language. And so we have here a JSON bucket policy, and this bucket policy here allows public read on our S3 buckets. So as we can see, it says effect allow principal star, so anyone, the action get objects on the resource example bucket / star, so on any objects within my S3 buckets. So this is great. This allows public access to our S3 buckets. So these bucket policies can be applied to your buckets and objects, so both. The actions is they allow a set of API to allow or deny. The effect is allow or deny. The principal is the account or the user that this S3 bucket policy applies to. And so some common use cases for S3 bucket policies is to grant public access to a bucket, or to force objects to be encrypted at the upload time, or to grant access to another account using cross-account S3 bucket policies. So we'll do in the hands-on a deep dive on S3 bucket policies. Then we have the bucket settings for block public access. So we've seen this in the hands-on when we get started. So this was a new setting that was created to block objects from being public if the account had some restrictions. So here we have 4 different kinds of block public access settings. We have the new access control list, any access control list, or new public or access point policy. So this is going to block objects and buckets from becoming public if they're granted through any of these methods. Or you can block public and cross-account access to buckets and objects through any public bucket or access point policy. So you don't need to remember these 4 different settings, okay? It's just a summary in here. What you need to remember going into the exam is that there is a way to block public access to your S3 bucket through these settings. The exam will not test you on each of these settings, okay? These settings historically were created to prevent company data leaks because there were a lot of leaks of Amazon S3 buckets in the news, and Amazon S3 came up with this way of making sure that an administrator could say, hey, none of my buckets are public, by the way, because of these settings, and that was very popular. And so if you know that your buckets should never ever be public, leave these on, and there's a way to set these at the account level, as we'll see in the hands-on. Other securities in S3 you should know about. On the networking side, you can access S3 privately through VPC endpoints. So if you have EC2 instances in your VPC without internet access, then they can access S3 privately through what's called a VPC endpoint. For logging and audit, you can use S3 access logs, and they can be stored in the other S3 buckets. API calls can also be logged into CloudTrail, which is a service to log API calls in your accounts. For user security, you have MFA delete, so multi-factor authentication is MFA, in which case, if you want to delete a specific version objects in your bucket, then you can enable MFA delete, and we will need to be authenticated with MFA to be able to delete that object. And finally, pre-signed URLs that we've seen briefly when we were opening that file, and there was a very, very long URL, which is a URL that's signed with some credentials from AWS, and it's valid only for a limited time. And the use case for it, for example, is to download a premium video from a service, if the user is logged in and has purchased that video. So the idea here is that anytime at the exam you see the access of certain files to certain users for a limited amount of time, think pre-signed URLs. So in the next lecture, we'll do a hands-on on S3 security to see all these various options. So I will see you in the next lecture.
Okay, so let's have a play with S3 bucket policies. To do so, let's go into permissions. And the goal for us is to define a bucket policy that we'll write in JSON. And this bucket policy is going to prevent uploading objects that are not encrypted. So let's edit this bucket policy. And we have two links. We have the policy example, which takes us to the documentation of AWS, if you want to have a read into all the kind of possibilities you can do to create a bucket policy. Or if you just want to follow along with me, then let's go into the AWS policy generator for S3 buckets. Okay, so let's generate our bucket policy. So first we need to select the policy type, and the type of policy we want is an S3 bucket policy. So please make sure to select S3 bucket policy. This is very important, otherwise you will not see the same options as me. Okay, so we have an S3 bucket policy here, and now we want to add a statement. So what we want to do here is to deny any object being uploaded into Amazon S3 that is not encrypted using, for example, the SSE S3 scheme. So we're going to have the effect to be deny, principal, so where from everywhere, okay? The action is an upload, so the API name to upload a file into AWS is called put objects. So we're looking for put objects here. And then we need to specify the ARN. So the ARN should be the bucket name / the key name. So let's go into the S3 Management Console. And here they provide us with the bucket ARN because they know that we're going to use it. So let's paste it. And so as I've pasted my bucket ARN, please make sure to add a star and then, a slash, and then a star at the end of the resource name. Why? Well, the action that we have selected, which is called put objects, as we can see right here, put objects applied to objects within the buckets. And so to specify to AWS we want to apply this to objects, we need to specify the bucket name, then slash star, and the star indicates any object within that bucket name. So we're saying, okay, deny anyone to upload an object anywhere in my bucket, and we need to add a condition, otherwise we would not be able to do many things with this bucket. So we'll add a condition, and the statement is null, so null. The key is going to be looking for the S3, so let's have a look, S3 XAMZ server-side encryption, so this one, okay, which is going to look for whether or not we have this header when we send a file to Amazon S3, and the value is true. So let me explain what I did. We're saying if this header is null, so that's the condition, if this header is null, then deny. And that makes sense. If this header is null, we are sending the file and we don't ask for any kind of encryption. So we'll add this condition, and this is our first statement. So let's click on add statement, and we'll add a second statement to repeat it. So we'll deny from anywhere, and then the action is going to be, again, the put object. So let's find it quickly. Put objects. The resource name has to be the bucket name /star. And for the condition, this time we're going to look at a second condition, and we're saying string not equal. The key is the same key as before, so the XAMZ server-side encryption. And then the value of it is going to be AES 256. So we're saying if the file is uploaded, but with the header, but the header value is not equal to AES 256, which is representing the SSE S3 type of encryption, then deny it. So we'll add the condition, add the statement, and here we go. We have generated our policy right here, which I can copy and paste into my S3 console. Save changes, and we're good to go. So here we have defined a bucket policy which denies any object being encrypted if it's not encrypted with SSE S3. So we can, for example, have a look. So let's upload an object and see if that works. So we'll add a file, we'll add coffee.jpg, and as we can see, I don't specify any encryption setting in particular. Okay, so it's going to go with none, and click on upload. It failed, and we can look at why it failed. So it failed, access denied, and so this is due to the buckets policy. So this is obviously good because this is what we expected to happen. And if we try to upload the same file, so coffee.jpg, but this time we are going to specify the encryption to be SSE S3, so by setting the right header, then this should work. So let's upload it and see. Yes, this has succeeded. And finally, let's try to upload this file one last time, but by specifying a KMS type of encryption. So let's go into override KMS using the AWS S3 KMS key and click on upload. And this has failed again because it doesn't respect the bucket policy. So the bucket policy is working just fine. And so how did I figure this out? So if I Googled S3 bucket policy deny encryption, this shows you the kind of blogs that shows you how to write this kind of, let me show you, of bucket policy. So this is not something invented. I use the documentation to refer for my courses, but I wanted to show you how to generate this policy using the AWS policy generator. Okay, hopefully this makes sense. Now, other settings that we may want to look at for security. So let's go into permissions. So if we go into permissions, we can see that there is block all public access setting. And so this is on by default, and this is to prevent any data leaks from AWS S3 into the world. And so we want to keep this on at all time unless we are running a public website and want to make the objects public. So we'll see how to do this in a future lecture. Also, we can define this block public access setting at my account level. To do so, on the left-hand side, I can do account settings for block public access, and I can block all public access of all my buckets if I wanted to by taking this box. So this is one more level of security. Okay? And then finally, for all my objects, so if I look at coffee.jpg, there is something called ACL or access control list. So I can scroll down, access control list. And this is something I won't linger on because we're not using this and the exam really doesn't touch it. But access control list is a way for you to define objects, read and writes at the object level. So as we can see right now, my account can read the object and read write thanks to the ACL. Anyway, I won't linger on it because this is not very important for the exam, but just know that ACLs are another way to protect your objects in AWS. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Okay, so just a quick lecture on S3 and Glacier Select. So the idea is that you want to retrieve a subset of your dataset in Amazon S3 or Glacier, and for this you're going to use SQL. And the SQL is going to be performing server-side filtering directly on the S3 or Glacier servers. The idea is that you can filter by rows or columns using simple SQL statements, so no aggregation, nothing like that, just a where clause. The idea is that thanks to this, you have less network transfer because you're only retrieving a subset of your data, and less CPU cost client-side to filter your data because you actually don't do the filtering yourself. So this works both for Amazon S3 and Amazon Glacier, but there is something for you to notice. Is that Glacier Select can only do uncompressed CSV files. And the exam can ask you a question about doing Glacier Select on compressed CSV files. In that case, what you have to do is to restore these compressed CSV files into Amazon S3 and then use S3 Select. You cannot use directly Glacier Select on compressed CSV file, only for uncompressed CSV files, okay? So let's look at an example. So before, if you wanted to filter some data, you need to retrieve the entire data set and do some filtering client side. But after using S3 Select, you can just filter Amazon S3 side. This gives you apparently 400% faster network time and up to 80% cheaper. So the idea is that we just run an S3 Select API call to get a CSV. Amazon S3 will do some server-side filtering, and then we only get the filtered data sets out of it, okay? So remember about this feature and remember about the Glacier Select caveat that it can only do uncompressed CSV files. And that will be it for me. I will see you in the next lecture. So now let's talk about S3 event notifications. And the idea is that your events are going to happen in Amazon S3. What are events? Well, events are things such as an object is created, or an object is removed, or an object is restored, or there is replication happening. And you can filter these events. So you can say, I only want to consider the objects that end with the JPEG. So the use case for event notification would be, for example, to automatically react to certain events happening in Amazon S3. For example, you want to generate thumbnails of all the images uploaded to Amazon S3. Therefore, you're going to create your event notification, and then you can send it to a couple of destinations. It could be an SNS topic, it could be an SQS queue, and a Lambda function. And don't worry if you don't know this by now, we will learn about these features in the next lectures. So you can create as many S3 events as desired, and you can send them to whatever target you want. So the idea is that these events are typically delivered within seconds to these destinations, but sometimes it can take a minute or longer. And those are the main three destinations you have to remember. But now there is a fourth one, and this is a new feature of S3 event notifications that has an integration with Amazon Event Bridge. So your events are going into your Amazon S3 buckets, and all the events end up in Amazon Event Bridge, no matter what. So all of them, okay? And then from Event Bridge that you don't know yet, but you can set up rules. And from Event Bridge, you can, thanks to these rules, send these events to over 18 different AWS services as destinations. So it really enhances the capability of S3 event notification. And again, we'll see Event Bridge later on in this course, but with Event Bridge, you get advanced filtering options, a lot more than what we had from before. So you can filter by metadata, object size, and name. You can send to multiple destinations at a time. You can set, for example, to step functions, can you see data streams or Firehose, or you even get the features coming straight from Amazon Event Bridge. So you can archive events, replay events, and you get more reliable delivery. Okay, there's a lot you don't know in this lecture around the new services, but let's just focus on Amazon S3 event notifications. The idea is that you can react to events happening in Amazon S3 thanks to sending it to SQS, SNS, Lambda, or Amazon Event Bridge. Okay, that's it. I will see you in the next lecture. Okay, so let's go ahead and demonstrate S3 event notifications. For this, I'm going to create a bucket. I call it Stefan v3 event notifications. And then we're in Ireland, and I will just go ahead and create my bucket altogether. Okay, so my bucket is created. I'm going to go into it. And what I'm going to do now is make sure that event notifications are set up. So I go to properties, scroll down, and then here we have event notifications. And as you can see, we have two options. Number one is to create an event notification, and I will show you this in a second. Or number two is to enable the Amazon Event Bridge integration to send all the events from this S3 bucket into Event Bridge. And for this, you just set it on and you'll be good to go. So it is something that now, if I wanted to, I could use Amazon Event Bridge to catch the events happening in my S3 buckets. But I will show you the simpler way, because it's a bit more complicated, is to just create an event notification and send it, for example, to SQS. So I'll call this one demo event notification. And then we can set up a prefix, a suffix, but I won't do it. And next we need to choose event types. So we want to react to all object create events. So that means that anytime an object is created, then an event is going to be created. But if you wanted to, you could get more granular and select which types of events you wanted. But to keep it simple, I'll take it here. And you can also include, for example, object removals, object restores, and it shows you all the events you can catch on the right-hand side. So I'll keep it simple. I'm just going to scroll down, but as you can see, there are a lot of different events you can react to in Amazon S3. And then you want to publish to a destination. And so we have three options. We have Lambda functions, SNS topic, and SQS queue. And I'm going to choose SQS queue, but we first need to create a queue and then authorize Amazon S3 to publish messages into that destination. So what I'm going to do now is just go into Amazon SQS and then create a queue. And I call this one demo S3 notification. I will go ahead and create this queue, and it's created. So now what I need to do is to enhance the access policy to allow my S3 bucket to write into my SQS queue. So to do so, let me first demonstrate the problem. So if I go back here and I am going to refresh this page to see my queue appear. So I refresh it and I say demo S3 events, all object created, and then scroll down and then choose the SQS queue. I can choose the queue ARN, I could choose the queue here in the dropdown, demo S3 notification. And if I try to save my changes, I get an unknown error, which is saying that, hey, you are not able to validate the destination configuration because this SQS queue does not accept yet messages from my S3 buckets. And so I need to change the access policy by clicking on Edit. Scroll down, here's my access policy. And I need to go ahead and generate a new policy. So I go to Policy Generator. It's going to be an SQS queue policy. And the effect is allow anyone, just to be very permissive, to do a send message. And my Amazon resource name is right here. I need to copy it and paste it. I add a statement and then generate this policy. And now this is the policy I want to use, which allows anyone to write to my SQS queue. So it's very, very permissive, but it will work. Let's save this. And now my access policy has been updated. So now if I go back here and try to save my changes, as you can see, the operation was successfully completed. And what happened is that if I go into my SQS queue and click on send and receive messages, and then click on poll for messages, as you can see, a message was being sent by Amazon S3, which is to test event to test the connectivity. So what I can do is I can take this message and delete it. So now we want to test whether or not the SQS event S3 event notification is working with SQS. So therefore, we're going to upload an object, click on Add Files, and choose our coffee.jpg. I will upload this file. Now the file has been uploaded, and if I go into my bucket, I can indeed see that my coffee.jpg has been created. And imagine we wanted to automate this and create a thumbnail from it. Then we would need to have a message into our SQS queue to then process it and create a thumbnail. Therefore, I'm going to poll for messages, and as you can see, a message was created here. And if we look at the message itself, and I'm going to try to increase this window size, we can see the fact that the event name was object created put, so an object was indeed created. And if we look deeper, we're going to see that the key of that message is coffee.jpg. So the coffee.jpg was created and it generated a whole event into my SQS queue. And therefore, that shows the power of S3 event notifications. What I can do here is I can delete the message and we're done. Okay, so that's it. We've seen S3 event notifications. What you need to remember again is that you can send to SQS, SNS, and Lambda, as well as send all events to Amazon Event Bridge for further processing and sending it to more destinations. Okay, that's it. I will see you in the next lecture. Now let's have a look at DynamoDB, which is a NoSQL serverless database. So if you consider the traditional architecture that we've seen in and out in this course, we have clients and they connect to an application layer that could be made of an elastic load balancer and EC2 instances that are grouped and scaling with an autoscaling group. And then the data has to be stored somewhere. So we have a database layer, and it could be using Amazon RDS, which is backed by MySQL or Postgres or these kind of technologies. Now, these traditional applications will leverage RDBMS databases, and we do so because we have the SQL query language. It's really good. And then we can define strong requirements about how the data should be modeled because we have tables, we have schemas, and so on. We can do joins, aggregations, complex computations, and that's all very good and working. What we get out of it, though, in case of scaling, is mostly vertical scaling. So in case you want a better database, and I'm talking just about database layer right now, if you want to scale it vertically, you need to replace the database and get a more powerful CPU, more RAM, or better disk with I/O. And you can do some sort of horizontal scaling, but this is by only increasing the read capability. So either by adding EC2 instances at the application layer, or by adding RDS read replicas at the database layers. But if you add read replicas, you're going to be limited by the number of read replicas you can have, and therefore limited into your horizontal read scaling. And I'm not talking about horizontal write scaling because you don't have that with RDS. So introducing to you NoSQL databases, which means not only SQL or non-SQL databases, depending on the definition. So the idea is that they're non-relational databases and they're going to be distributed, which gives us some horizontal scalability. And some very famous technologies that have NoSQL databases are MongoDB and, of course, DynamoDB. Now, these databases do not support query joins or have very limited support. And so for simplicity, I just assume that they don't have query joins. Now, all the data that is needed, therefore, must be present in one row in your database. And again, to simplify things, I know they're evolving, but let's just assume that NoSQL databases also do not perform aggregation computations, such as the sum or the average and so on. But the good thing out of it is that thanks to the design, the NoSQL databases will scale horizontally. That means that if you need more write or read capacity, you can, behind the scenes, have more instances and it will scale really well. So there's no right or wrong for NoSQL versus SQL. It just depends on how you think about your modeling of data, about your application, about your user queries, and about your scaling needs. So let's talk about DynamoDB now. So DynamoDB is a fully managed NoSQL database, and it's highly available and has replications across multiple AZs out of the box. So it's a NoSQL database. It's not a relational database, so it's different than RDS. It scales to massive workload and is fully distributed. That means that you can scale to millions of requests per second, trillions of rows, and hundreds of terabytes of storage, regardless of your workload. So fast and consistent performance. So that means you get really low latency on retrieval. And it's an AWS service, so it's going to be fully integrated with IAM for security, authorization, and administration. You can enable event-driven programming with DynamoDB streams, as we'll see in the section. It's low cost and has auto-scaling capability. And you have the standard and infrequent access IA table class for different storage tiers. So let's have a look at the basics of DynamoDB. So DynamoDB is made out of tables, and each table will have a primary key, and we'll see what the primary key can be in the next slides. You must decide what the primary key is before you create your table. Now, each table can have an infinite number of rows, also called items. So I will use rows and items term interchangeably in this course. And each item will have attributes. Now, these attributes could be similar to the columns in your table, okay? But these attributes can also be nested, so it's a bit more powerful than columns. And they can be added over time. You don't need to define them all at creation time of your table. And some of them can be null. So it's completely fine for an attribute to be missing in some data. Now, each item or each row will have up to 400 kilobytes of data, so it's a limitation. And data types supported are going to be scalar types, so string, number, binary, boolean, and null. There's going to be document types such as list and map, so that gives you some kind of nesting capability, and set types such as string set, number set, and binary set. Now, a very important point to understand is how to choose a primary key for DynamoDB, and the exam will definitely test you on the knowledge of this. So you have two options for primary keys, and the first one is called a partition key, which is called also a hash strategy. So the partition key in this case must be unique for each item, which is very similar to a normal database. And therefore, the partition key must be diverse enough so that your data is going to be distributed. For example, if you consider user ID for users table, then we can have the partition key as being user ID, the attributes as being first name, last name, and age. And then you have your first user ID with some attributes being filled out. Your second user ID, as you can see, does not have a last name, but this is fine in DynamoDB. And the third partition key, yet again, has 3 attributes attached to it. So this is what DynamoDB looks like. It looks like a database for now. It's pretty easy. But you can have a second option of partition key and sort key, also called hash plus range. And now the combination of these two items must be unique for each item. So the data is going to be grouped by partition key, and this is why it's very important to choose a good partition key. So if we consider a user's game table, then user ID for the partition key and game ID for the sort key. Let's see what that means. That means that users can attend multiple games. So we have these four columns, attributes, but the first one is going to be our partition key. We want data to be grouped by user ID. And the second one is going to be the sort key. This is going to give us the uniqueness of the combination of partition key and sort key. So both of them are going to be making the primary key, and the rest are going to be attributes. So if you consider a user ID, then it has a sort key, which was the game ID, and then we attribute score 92, result win. Again, another different user ID and another different game ID. So this works as well. We have a lose game with a score of 14. And more interestingly, in this third row, what we have is that we have the same partition key, okay? So row 2 and 3 have the same partition key, but a different sort key. Of course, it is fine for a user to attend multiple games, and so therefore you want the combination of user ID and game ID to be unique, obviously. But it's fine to also have the same partition key and different sort key. And this is why it's super important to choose a really good partition key so the data is going to be distributed enough. So here's an exercise, and this is what the exam may test you on as well. So you're building a movie database, and you want to choose what is the best partition key that is going to maximize data distribution. Is it movie ID? Is it producer name? Is it leader actor name? Or is it movie language? Well, think about it for a second. What if you choose the first one, what if you choose the second one, and so on? Now, the answer is you choose movie ID, because movie ID is going to be unique for each row, and therefore it's a really good candidate to partition your table by. If you have a movie language as a partition key, then you won't have as many values as you want, and maybe most of your movies are going to be towards English, so it's not going to be a great choice because there's not enough diversity and there's a skew of data towards one specific value. And so the exam will ask you to choose the best partition key for some tables based on what it means. So always choose the one with the highest cardinality and the one that can take on the most amount of values. So that's it for a short overview of DynamoDB. We have a long section on it, but let's go over the hands-on to practice a little bit using DynamoDB. So now let's have a look at the DynamoDB service. And DynamoDB service is going to allow us to create tables. So as you can see, we can create tables, not databases, because, well, the database is already created for us, and this is a serverless offering, so we just go ahead and create tables. So the table name has to have a name, so we'll enter users, and then we have to define a partition key and optionally a sort key. So for partition key, I'll use user underscore ID, and then we can choose a type, so it could be binary, number, or string, but I will leave it as string. And then we can use a sort key, but I will show you this later on, so currently we'll leave it empty. Now, the quick start allows you to start with the default settings, and it sets some settings for you, or you can go ahead and customize the settings, but because we are learning about DynamoDB, let's go ahead and learn about custom settings. So the first thing is around table class. So it's either DynamoDB standard, which is a general purpose table class, which is recommended for most use cases. But if you have data that's going to be sitting around for a long time and you're not going to have a lot of reads or writes, then DynamoDB standard IA is going to say that the data is infrequently accessed and give you some cost optimizations. But right now, we'll use the default, which is DynamoDB standard. Capacity calculator, we'll see this later on because we have to understand how to compute capacity in DynamoDB. But for now, we don't do anything in here. And then two modes for read and write capacity, on demand or provisioned. And provisioned is within the free tier. Again, we'll have a long discussion around these modes later on, but we'll use provision because it is within the free tier. Next, we have to set up the read and the write capacity. And I'm going to disable auto-scaling for both. So we just provision a fixed read and write capacity. And we have two capacity units within the free tier. So I'm going to set up, we have 10, sorry, within the free tier. So I'm going to set up two provision capacity units for reads and two for writes. And we'll see how we make them evolve over time. We're not going to create a secondary index for now because this is something that's going to be advanced later on in this course. And here we get the estimated cost for this table, which is $1.32 per month. Now, because we are within the free tier, you can disregard this number, okay? But if you were not within the free tier, this would be how much this table would cost you per month. Then we will encrypt the data at rest using the DynamoDB key. We'll leave it like this, but we have other options. And when you're ready, you click on Create Table. Okay, so my table has now been created. I can click on it and I will remove the left panel. And as we can see, we get a lot of information around our table. So around the settings for our table, so which one is the partition key, the sort key, the capacity mode, and there's some replication that created and so on. So a lot of information. And for us, the important things is going to be around the items. So if I scroll down, there's like view items, or if I go on the right-hand side, there's also view items. Now, as we can see, I can scan or query my table, but what I'm going to do is just create an item. So in this create item, I can choose a user ID, and we need to define the partition key. So for example, John123. And this is just a user ID, a random one. You can enter whatever you want. And then we can add attributes for John123. So we can add a string, for example, and the string is going to be first underscore name. And the value is going to be, well, John. And then if we have a string and it's last underscore name, then we can have Doe, John Doe. And as you can see, we could add many attributes as we wanted of these types. So we're good to go. We're going to just create an item. And as you can see, this could be either through a form or through a JSON document. So we'll just keep it as a form and create this item. So now this item, John Doe, is appearing in my table. As you can see, we have user ID, first name, and last name. So what we can do is to start adding a second item. So let's create a second item. And if I keep John123 as my value, and then I will just say Johnny as my first name, for example, just to show you something. If I do so and click on create item, I'm going to have a problem because, well, I'm using the same user ID as before, and it has to be unique when I have just a partition key. So this does not work. Okay, so what I can do instead is I can create Alice 456, and the first name is going to be Alice. We don't know her last name, so we're not going to specify last name, but we know her age, and her age is 41. Now, if I try to create this item, something very interesting will happen. So as you can see, the request was successful. So in a RDS SQL database, you would have had a problem saying the column was not defined, some values are null, whatever. But here, we're able to get John to have a first name and a last name, and Alice to just have an age and a first name. So in DynamoDB, it is completely fine for you to add attributes over time, okay? The only thing that has to be non-null is the user ID. But as we can see, things get null by default. So John has a null age, and Alice has a null last name, but this is fine. So this is the power of DynamoDB, also a risk, but also the power. You can add attributes over time without impacting your previous data, and this is completely fine, okay? You cannot define in DynamoDB a constraint of this column must not be null. It just doesn't exist, okay? So we have our first table being created, but it's super easy to keep on creating tables. So if I go back to DynamoDB and click on create table, we can create a second table called users post, okay? Or user post. Okay, now the partition key is going to be yet again user ID, but now we're going to have a sort key, which is post TS for a timestamp, again, of type string, binary, or number. And what we want to create here is we create a table of data, which will have the post of the users. And so again, we're going to customize the settings, and we're going to use provisioned. Auto-scaling is off, and we're going to have it 2 and 2. And then scroll down and create this second table. So as we can see now, I have two tables in my database. And again, no need to say what's happening to the table, what's the underlying database. It's really, you can create as many tables as you want within your quote unquote DynamoDB database, which is done at the region level. So now let's go into user post. And now we can see that there's a partition key and a sort key being defined. So if I go to view items, and then I'm going to create an item, now we need to specify a user ID, for example, John123, and a post timestamp. So for example, 2021, 10:09. I'm not even sure if that's the correct timestamp, but let's hope it is. TS, and then a time, so 123409Z. Okay. So next we need to add some content for our post. So I will say content and say, hello world, this is my first blog. Okay, excellent. Now let's create this item. And as you can see now, we have user ID John and post timestamp this and some content. So now what happens if we create a second item? Well, we can keep John123 as my user ID. And for the post timestamp, I'm going to just have 2021, maybe something a bit later, so 11 04 T, and then again, just a random timestamp. Okay. And we're going to add a new content and say second post. Yay. Okay. And create this item. So as we can see, this has worked. So even though we have the same user ID, because the post timestamp was different, we were able to enter this data into my table. So the uniqueness has to be on user ID and post timestamp as a combination. And so that means that the data is partitioned by user ID. So this is why John is clickable, because we can query and search for John123 as my user ID. And then we can sort the data by post timestamp. Okay, so it's called a sort key. So this is very, very, very handy. And as we can see, if we wanted to create one last item, and this was for Alice 456, again, you will need to enter a post timestamp and some content, and you'll be good to go. And so this is why it's super important to choose a really good partition key in these kind of moments, because if you choose a partition key that keeps on coming back, so if John123 is the only user that posts and you have 10,000 posts, then the data is going to be heavily skewed toward John123. So there's something to be aware of, okay? So that's it for this lecture. I hope you liked it, and I will see you in the next lecture.
Now, how does DynamoDB relate in the big data world? Well, there's some very common use cases that includes mobile apps, gaming, digital arts ad serving, live voting, audience interaction for live events, sensor network, log ingestion, access control for web-based content, metadata storage for Amazon S3 objects, e-commerce shopping cart, web session management. So the use cases are quite diverse, but basically that means that anytime you have some data that needs to be very hot, that needs to be ingested at scale within a database, DynamoDB is going to be great for that. In terms of anti-pattern, what don't you do with DynamoDB? Well, for example, an application that uses RDS like a traditional database, like a RDBMS, then you want to use RDS instead because you don't want to rewrite it entirely. Or if you need to have joins or complex transactions, then DynamoDB may not be the best friend for this. Maybe again, an RDS database may be better for you. If you need to store binary large objects or blob data, so big data, maybe it's better to store in S3 and store the metadata in DynamoDB. This is a very common pattern. And in general, if you have large data that has low I/O rate, so very little writes or very little reads, S3 is going to be a much better storage option for you. So think about it. DynamoDB is going to be more for when your data is hot and smaller, while S3 is going to be more when your data is a bit colder, but much bigger.
Okay, so now let's talk about read and write capacity modes for DynamoDB. So this is how you control your table's capacity. So you have to specify in advance the read and write throughput. So you have two modes actually. The first one is called provisioned mode, which is the default mode, in which we specify the read and writes per second, so also called read capacity unit and write capacity unit. So you need to plan your capacity beforehand. You're going to pay for whatever is going to be provisioned. So if you say I want 10 read capacity units and 5 write capacity units, you're going to pay for that every hour. And you have the option to do auto scaling, as we'll see very soon. There's the second mode called the on-demand mode, and this one will automatically have the reads and the writes scale up and down based on your workloads. And there's no capacity planning needed, so you don't need to provision capacity units. They will just be there, and you're going to pay exactly for what you use. But it's going to be a lot more expensive than provision mode. So the idea is that you have different use cases, and we'll see them in this lecture in details. So you can switch between the two modes, provisioned and on-demand, once every 24 hours. So we're going to do a deep dive on both of them, so do not worry right now. It's just an introduction. But now let's do a long deep dive on provisioned read capacity mode. So you must provision read and write capacity units, also called RCU, which is the throughput for reads, and WCU, which is the throughput for writes. Now you have the option to set up auto-scaling of throughput to meet demand, so don't you think too hard about your RCU and your WCU value. You just say, what's your target capacity usage, and DynamoDB will scale those for you. Now, in case you go over the RCU and over the WCU because you are consuming more or writing more than what you provisioned, it's completely fine because you can tap into temporarily what's called a burst capacity. But if you exhaust the burst capacity because it's been fully consumed, then you're going to get an exception called the provision throughput exceeded exception, which is very obvious about what it is. Then, in case you get these things, you need to obviously retry, and the strategy to retry your writes or your read is called the exponential backoff retry strategy. Now, let's look at WCU in detail. So the exam will ask you to perform some computations, and so therefore you need to understand the formulas to compute WCU and RCU. So one write capacity unit, WCU, will represent one write per second for an item of up to 1 kilobyte in size. And if your item is obviously larger than 1 kilobyte, then you're going to consume more WCUs. So let's go through examples to understand the computation. And you can pause this video if you wanted to do the computation on your own. So if you write 10 items per second and the item size is on average 2 kilobytes, how many WCUs do you need? Well, we do the math. We need 10 items per second, so 10 times, and then the item size is 2 kilobytes, which would divide by 1 kilobyte, which is the number of WCU you need for 1 kilobyte, and you get a result of 20 WCUs. So this was a very easy example. Now in example 2, we write 6 items per second, and this time the item size is 4.5 kilobytes. So it's a little bit trickier, this one. So we need 6 times 5 divided by 1, which is 30 RCU. Why? Well, because the 4.5 kilobytes is always going to be rounded to the upper kilobyte by DynamoDB to get an idea of how many WCUs you've consumed. So remember, you need to round to the upper kilobyte for WCUs. Now, if you write 120 items per minute and the item size is 2 kilobytes, the trick here is that we have items per minute, so you need to do a small computation, which is 120 divided by 60 to get items per second, and then this gives us 4 WCUs. Okay, so write capacity units are very basic and honestly very easy to understand. The more complicated ones are going to be around reads. So first, we need to define two kinds of read modes for DynamoDB, which is the strongly consistent read and the eventually consistent read. So if we consider DynamoDB, it's a serverless database, of course, but behind the scenes, there are servers. You just don't see them or manage them. So we have servers, and let's just consider 3 servers right now to make it very, very simple, but it's obviously a lot more. And your data is going to be distributed and replicated across all these servers. Now, if you consider your application is going to do writes to one of these servers, and internally, DynamoDB is going to replicate these writes across different servers, such as server 2 and server 3. Now, when your application reads from DynamoDB, there is a chance that you're going to read not from server 1, but from server 2. Now, 2 things can happen, right? If we are in eventually consistent read, which is the default mode, then if we do a read just after a write, it's possible that we'll get stale data because the replication has not happened yet, if we're very, very quick. But after, say, 100 milliseconds, you're good to go, obviously. But if you do a strongly consistent read, you're saying, hey, I want to read the data just after the write, and you're going to get for sure the correct data that was just written. For this, we need to set a parameter called consistent read in our API to true, and it could be applied to get item, batch get item, query, and scan. And why wouldn't we do this all the time? Why wouldn't we want to have strongly consistent reads all the time? Well, it's going to consume twice the RCU, so it's going to be a more expensive query, and also may have a slightly higher latency. So you need to ask yourself, do I need eventually consistent reads or do I need strongly consistent reads? Now, let's talk about RCU regarding these 2 things. One read capacity unit, RCU, represents 1 strongly consistent read per second, or 2 eventually consistent reads per second for an item of up to 4 kilobytes in size, which makes the computations a little bit trickier. And if your items are larger than 4 kilobytes, more RCUs are going to be consumed, and again, it's going to be rounded up to the nearest upper 4 kilobytes. So let's go through examples again, and feel free to pause the video. So if you have 10 strongly consistent reads per second, and the item size is 4 kilobytes, how many RCUs do you need? Well, you need 10 times 4 kilobytes divided by 4, which is equal to 10 RCUs, okay? Now, if you have 16 eventually consistent reads per second, and the item size is 12 kilobytes, so this is a bit more complicated, this one, we're going to get 16 divided by 2 times 12 divided by 4, which is 24 RCUs. So in this example, obviously, we need to divide 16 divided by 2 because we have 2 eventually consistent reads per second in 1 RCU, and then we divide 12 by 4, which gives us 24 RCUs. And last example, which is 10 strongly consistent reads per second with an item size of 6 kilobytes, okay? So this one is a little bit trickier. So what is it? Well, it's 10 times 8 divided by 4. And why 8? Well, we round up 6 kilobytes to the nearest 4 kilobytes. So it's going to be 8 kilobytes, and you have to always go up, okay? And in this case, we get 10 times 8 divided by 4, which is 2, so 20 RCUs. So now that we know about WCUs and RCUs, let's talk about how DynamoDB works in the backend with partitions. So DynamoDB is made of tables, and each table has partitions. And partitions are just copies of your data that live on specific servers. Now, when your application does writes into DynamoDB, what's going to happen is that your application will send a partition key, a sort key maybe, and some attributes. And all this data is going to go through a hashing algorithm. So only the partition key actually is going to go through a hashing algorithm to understand which partition to go to. So if we take the partition key of ID 13, it's going to go through this internal hash function of DynamoDB, and it's going to say, hey, anytime I see ID 13, this is going to go into partition 1. And if you have ID 45 in the second row, then ID 45 is going to go through the hash function, and the hash function will say, hey, this ID 45 should go to partition 2, and this is how your data gets distributed. So obviously, if you have what's called a hot partition, the data is always going to be a hotkey. The data is always going to be into the same partition. So to compute the number of partitions, there are some intense formulas that you do not need to know for the exam. So let's go over them very quickly. But you compute the number of partitions by dividing the RCUs by 3000 and the WCU by 1000 and adding those up. You can also have a look at how much data you have. So total size of your data set divided by 10 gigabytes. And then the number of partitions is going to be the max of these two things. Now, you don't need to know this formula, so do not worry about it at all, okay? But what you need to understand, though, is that if you have 10 partitions, then you provide and you provision 10 WCUs and 10 RCUs, then they're going to be spread evenly across partitions. That means that each partition is going to get one WCU and one RCU. And this is the point I want you to remember, okay? WCUs and RCU are going to be divided and spread evenly across partitions, which brings us into throttling. So in case you exceed the RCUs or WCUs, and this is at the partition level, then you're going to get a provision throughput exceed exception. So maybe because you have a hotkey, so one partition key is being read too many times from a specific partition, which is because maybe you have a popular item, or hot partitions, or very large items, because obviously when WCU and RCU is computed, it depends on the item size. And so if you read or write a very large item, you're going to consume a lot of RCU or WCUs. Now, solutions for attacking this provision throughput exceeded exception is number one, to do exponential backoff when the exception is encountered, which is, if you're using the SDK, something that's already included. You have to distribute the partition keys as much as possible, which was the exercise we did in the first lecture to understand how we can choose a really good partition key. And if this is an RCU issue because you're reading one data point on one partition very, very heavily, then we'll have a look at the feature called DynamoDB Accelerator, or DAX. Now, the last mode we need to understand, and this is a much easier mode to understand, is the on-demand read-write capacity mode, which is going to automatically accept any reads and any writes, and is going to scale up and down based on your workload. So there's no capacity planning needed. You do not specify the RCU or the WCU. It's unlimited. There's no throttling, but obviously this is more expensive. And you're going to charge for the actual reads and writes. This is what is called read request units, so RRUs, and write request units, which is WRUs. The computations are the same, but the idea is that because we have every request that succeeds, it's not a capacity we talk about, it's just on the request. Now, to give you some overview, on-demand is about 2.5x more expensive than provision capacity. So make sure that you have it only for specific kind of use cases, for example, unknown workloads or when it's unpredictable application traffic. So that's it for capacity modes in DynamoDB. I hope you liked it, and I will see you in the next lecture. So let's have a look at how we can define the RCU and WCU of our tables. So if we take our users table, for example, and you go on the right-hand side and you do additional settings, you have the read-write capacity, and you can edit it. So this is what we had defined at table creation time, but the cool thing about DynamoDB is that we can switch between the capacity modes if we needed to, and then we can also change them over time. So let's take the most simple capacity mode right now, which is on-demand. And this is simplified billing for paying for the actual reads and writes of your application. But this is twice or 3 times as more as expensive as provisioned. And so obviously this is when you have a very unusual, unpredictable type of workload, or maybe this is like in your development environment, and let's consider that you're not using the table at all for like 24 hours a day, but maybe one day for 1 hour, you'll be using the table a lot. And so therefore, this is a great capacity mode because it actually bills you for what you've been using, which is quite amazing. Now there is provision capacity mode, and this is the one we spent most of time on to understand and to compute the reads and writes. And so let's go into the capacity calculator. So as we can see here, you can specify the average item size, for example, 6 kilobytes, how many reads per second you want, so maybe 3 reads per second and 2 writes per second. The type of reads you want to have, so eventually consistent and strongly consistent. There's transactional, but I will define this a bit later on. I didn't want to overwhelm you right now. So eventually or strongly consistent. And then for the write consistency, same standard or transactional, but again, transactional, we'll see it a little bit later. And as we can see, based on what I choose, it gives me the RCU and the WCU as well as the estimated cost I will have for my table. So this is quite a handy calculator, and I would suggest that you practice a little bit with these settings and you try to guess correctly what's the RCU and WCU for this table, because this is something that the exam will ask you. Cool. Now let's take a look at the table capacity. So we can obviously have off autoscaling and off autoscaling for a read and writes, and so therefore you need to provision capacity units, and they won't change over time unless you manually change them. But you can also set up autoscaling. And autoscaling is really cool because we're just saying what's my min and my max I'm willing to consider, and what's my target utilization as a percentage. And DynamoDB will try, for example, if we have maximum capacity of 100, it will set it to 100, the WCU, if you're actually consuming on average 70 WCUs and so on. But if you're consuming, say, 7 WCUs, then automatically the autoscaling will kick in and the desired capacity units will be 10 for that table. So autoscaling is nice because you don't have to think too hard about setting the WCU and RCU. You just need to think about what's my min, what's my max, and what's my target utilization, and your application and DynamoDB will do the rest, which is nice to have a better pricing and a better scaling. Okay, so this is applying to both autoscaling for reads and for writes, so this is good. And then you would get the estimated cost and so on. So if I set it to autoscaling max 3 and min 1, and then again max 3 and min 1, and click on Save Changes. Now what I'm going to do is just to wait a little bit of time for autoscaling to kick in and to see the autoscaling activities. Now as we can see, the provision was 2 and 2 for WCU and RCUs, but we had 1, 2, 3 in terms of range for autoscaling, and I refreshed autoscaling activities. And as we can see for this table, the setting read capacity was set to 1 and write capacity was set to 1 because I'm not using the table, and so autoscaling kicked in and it worked. And so therefore, if I refresh this page and remove this here, as we can see now, the RCU and WCUs are 1 and 1. So autoscaling is quite cool. It works just like EC2, but for DynamoDB. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. In the exam, you will see the API calls of DynamoDB referred by their name. So it's good for us to see them once. So if you want to write data, you have a few options. You have put item. And when you do a put item, it creates or fully replaces a new item that has the same primary key. It will consume write capacity units. And so the idea is that you want to do a full replace or writing a new item. The second one is update item, which is a bit different than put item. This one will edit the existing item's attributes, or we'll add a new item if it does not exist. But the idea was that with update item, we only edit a few attributes, not every other attribute. So this is the difference between put item and update item. And we can use it with atomic counters that we'll see in this section as well. And then you have conditional writes, which is to accept a write, update, delete only if a condition is met. And this is helping with concurrent access to items, and we'll see this as well in this section. To read data, we have a get item, and get item is very simple and easy to understand. You read based on the primary key, and the primary key again can be a hash or a hash plus rand, so you have the two options, and you get two modes to read from. So you have the eventually consistent read mode, or to have strongly consistent read modes, but you need to specify it. It will take more RCU and there may be a little bit more latency. You can also specify a projected expression in your API. And this projection expression is going to help you receive only a few attributes out of DynamoDB. Next, we have the query. And the query is to return items based on a key condition expression, which is a partition key. So it must be the equal operator. So you're saying, hey, I want to query for John123. And also optionally a sort key. And because you can sort, then you can have equal, less than, over than, begins, between, and so on. Then you can specify a filter expression. And this is to add additional filtering after the query operation has been done, but before the data is returned to you. And this is to use with non-key attributes. So you cannot use a filter expression with hash or range attributes. And what the query returns is going to be a list of items, obviously, and you have a limit of how many items you retrieve based on the limit query parameter. And either you're going to reach that limit of number of items or you're going to get up to 1 MB of data. But if you want to get obviously more data over time, you can do pagination on the results and ask for more and more and more. Now you can query a table or a local secondary index or global secondary indexes, and we'll see those in the next lectures as well. And finally, you have a scan. So get item was for one item, then the query was for a specific partition key and a sort key. And scan items is to read an entire table. And then if you wanted to, you could filter it, the data, but this is only done client side. So this is very inefficient. So scan is to really export the entire table. And each scan will return up to 1 MB of data. And if you want to keep on reading, then you need to use pagination techniques. So that means page 1, page 2, page 3, and so on. It will consume a lot of RCU because you are reading your entire table. And so therefore, if you want to not impact your normal operations, you need to impact the scan using a limit statement or to reduce the size of the result and then pause a little bit. And if you wanted to instead consume a lot of RCUs and do a scan as fast as possible, then for faster performance, you would use a parallel scan. In this case, multiple workers that you define will scan multiple data segments at the same time, which will increase the throughput and RCU consumed. And if you wanted to still have a parallel scan and limit its impact, you could use limit queries, limit conditions, and so on. And then scans can be used with projection expression and filter expression. So projection expression to only retrieve certain attributes and filter expression to change stuff client side. Now, if you want to delete data out of DynamoDB, you have the delete item, which is used to delete an individual item. And then you can also do a conditional delete. So delete this item only if money equals 0. And if you want to delete everything in your table, you have delete table. So this is to delete a whole table and its item. And it's much quicker than doing a scan and then deleting every single item on the table. Okay, delete table will just drop everything. And this is something that can come up in the exam. If you wanted to just delete everything, do not do a scan, just use the delete table API. And finally, because this is a very efficient database, you can batch operations by reducing the number of API calls you do. So these operations are done in parallel for better efficiency, and part of a batch can fail, in which case you need to try again for the failed items. So the two batch operations we can do is number one, batch write items, which you get up to 25 put item and or delete items in one call. And so you can write up to 16 megabytes of data with up to 400 kilobytes of data per item. And you cannot update items. You need to use the update item API for that, but you cannot do a batch update item. And then you can do batch get item, which is to read items from one or more tables at a time. You get up to 100 items back, up to 16 megabytes of data. And the items are going to be retrieved in parallel to minimize latency. Okay, so you've seen all the API calls you need to know for DynamoDB. I know this was a lot, but hopefully they make more sense once you see them in the exam. So I hope you like this lecture, and I will see you in the next lecture. So let's have a look at these data API calls we can do. So if I go on my table, as we can see right now, we are in the scan, and we can select a table, and then we click on run. So scan is going to scan the entire table and obviously going to return many items to us. If we wanted to create an item, what we could do is specify user ID, so Alice456, then we specify a timestamp. So let me just do this one very quickly, and then T 0506 and 00, here we go. Okay, and then some contents for it. Alice blog. Okay, now let's create this item. So this was a put item. Why? Because we have sent a new item into DynamoDB and we specify user ID, a post timestamp, and this was new, so it will get created. If you want to look at update item, what I can do is action and then edit, and then I will just edit one specific attribute. So add Alice blog edited and click on save change. And behind the scene, this is going to do a update item API call. So we have seen updates. Now let's look at get. So if I click on this one, for example, and I'll go into the item editor. Well, behind the scenes, by clicking on this row, on this item, I was able to retrieve the content of this item. And so this was a get item that was done. So this is good. Now we can do obviously batch actions. So we can do action and then delete items, which will be a batch delete item. Okay, so batch writes and a batch deletes. But if you wanted to delete everything in the table, you could do a scan and a batch delete, but this would not be very efficient. The other way to do it would be to simply drop the table and be done. Now, finally, let's have a look at scan and query. So scan really gives you all the tables you have, and then you can apply a filter if you wanted to, but this is done client side for this filter. So this will be filtered in your web browser, not in DynamoDB directly. Or you can do a query. And a query is very helpful because we can specify a specific user ID, for example, John123, and then click on run. And this gives us all the items of John123. But also we could have a query and specify a condition on the post timestamp, which is a sort key. And so we can have equal to, less than equal to, greater than, between, and begins with. So if you wanted to know all the posts after, say, 2021-11, and click on run, we will only get one return item. But then if we do 2021-09, we get two items back. So as you can see, the queries here is only done on user ID and post timestamp. We cannot query on the content or search for the content. We could filter on the content if we wanted to afterwards, but this would be done client side. So this really shows you the power of using partition keys, such as a hash key and a sort key, okay? So that's it. We've seen all the APIs of DynamoDB. Now let's just do a scan and retrieve all the data. So I hope you like this lecture, and I will see you in the next lecture. Okay, so now let's talk about indexes for DynamoDB. And you have two kinds of indexes that you need to know. The first one is a local secondary index. So a LSI is going to give you an alternative sort key for your table. So you have the same partition key from your base table, but you're going to get an additional sort key. And this sort key consists of one scalar attribute, so it could be a string, a number, or a binary, and you can get up to 5 LSIs per table. Now, LSIs must be defined at table creation time, so you cannot create them after your table has been created, so you need to have some careful thinking into how you want your table to be designed. Next, on your LSI, you can have some or all attributes, from your main table. So it's up to you to choose in your LSI if you want to only have maybe one specific attribute because this is what you're trying to query for. So if we take an example of here, this is our table, which has user ID, game timestamp, score, and results, okay? And right now we can do queries on user ID and game ID very simply, but we cannot do a query on user ID and game timestamp. For this, we need to do a scan and then do some some client-side filtering. So to do so, if we wanted to do a query based on user ID and game timestamp, we would need to create an LSI and define the LSI on the attribute game timestamp. And if we do so, then we can do a query on, hey, give me all the games that have been done by this user between 2021 and 2020, and so on, okay? So this is super important for you to understand. This is the same partition key as before, but we have a different sort key thanks to an LSI. Next, we have GSI, or Global Secondary Indexes. So this is going to give you an alternative primary key. So you could have a different hash key, a different partition key, or you can have a different hash key and sort key as well from the base table. So this is helpful if you wanted to speed up queries on things that are non-key attributes within your table. So the index can consist of scalar attributes, so string, number, and binary. And again, you can specify which attributes you want to project on that index. And for that index, though, it's very special because it's kind of like a different new table. And therefore, for this index, you must provision the RCU and WCUs. Now, the GSIs are powerful because they can be added or modified after the table has been created. So let's take a very simple table in which we have user ID, and game timestamp. With this table, we're able to query based on user ID. So give me all the games of this user. But we cannot query on game ID. As we can see right now, if you wanted to query on game ID, it would be extremely difficult. We need to do a scan and then filter client side. So instead, we're going to create a GSI, a Global Secondary Index, okay, which is going to give us the ability to query by game ID. So now the partition key for that GSI becomes the game ID. The sort key may be, for example, game timestamp, if this is what you want to query on, and the attribute become user ID. because we've done a projection of the user ID attributes. So as you can see in this one, we're creating some fully different new queries by defining a new partition key and a sort key. And this is why it's very important in DynamoDB to understand how you're going to query data, to understand how you're going to make your local secondary indexes and your global secondary indexes. So we've seen LSI, we've seen GSI, very, very different purposes. But let's talk about these indexes and throttling. So when you have a GSI, if the writes are throttled on the GSI, then the main table will be throttled as well. So this is a very, very important caveat that comes up in the exam. So even if the WCUs are fine on the main table, if they're throttling on the GSI, then the main table, no matter what, will be throttling. And therefore, choose your GSI and partition key carefully and assign your WCU capacity very, very carefully. Whereas for LSI, so local secondary indexes, they will use the WCU and the RCU of the main table, and there's no special throttling considerations to be had, okay? So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So let's have a look at how we can create indexes. So back into my tables, I'm going to create a new table, and I'll call this one demo indexes. And we need to choose a partition key. So let's choose user ID and a sort key game timestamp. So this is allowing us to query on user ID and game timestamp. And for this, I'm going to customize settings. I'm going to say I want provision capacity of 1 RCU and 1 WCU. Great. And here we can define our secondary indexes. So you can see we can create either a local index or a global index. Now, local indexes can only be created at table creation time, whereas global indexes can be created afterwards. So we can create a local index, and here we need to specify a different sort key. So as you can see, we do not have the option to specify a different partition key. So user ID will remain the partition key for this index, but we can specify a different sort key. So for example, let's say I want to create a local index, and the sort key is going to be called game ID. So now the index name is game ID underscore index. And then what attributes do we want to project onto this index? We want all, only the keys, or only include specific attribute names that we specify. So we'll keep it simple and have it as all. So we just created this index, and we could go ahead and create a global secondary index in which we have the option to specify a different partition key and optionally a different sort key, as well as project some attributes. So let's just for now not create this global secondary index, which is going to create a local index, okay? And then click on create table. Okay, so my table is now created, and let's have a look at how we can query it right now. So if I go into query, as we can see, I can query either a table or an index and have two options. I can query my demo indexes, which is my table, so I can specify a user ID and a game timestamp, or I could query my index and specify a user ID and a game ID. So as we can see, this local index allowed me to query by a different partition key, a different sort key, with the same partition key. So let's go back into the table details and let's go into the indexes tab. So as we can see, there is one local secondary index that has been defined, so this one, and we cannot create another one. So LSIs have to be defined at table creation time and not afterwards. Whereas GSI, so global secondary indexes, can be created afterwards. So we could create an index and we could enter a completely different partition key, for example, game ID, and a sort key could be, for example, game timestamp, okay? And this gives me a GSI. Now we need to also create some capacity for my GSI. So the local secondary indexes tap in the RCU and WCU of the main table, whereas for a global secondary index, you need to create your own read and write capacity. So either we copy from base table, or we customize settings and we can again specify auto scaling on and off. So we'll just copy from base table and have a 1 and 1 for RCU and WCUs. And then what attributes do we want to project? And then this global secondary index is going to be created. Now remember, if you query a lot that GSI and writes get throttled, then the writes will be throttled as well on the main table, whereas the LSI just taps into the RCU and WCU of the main table. Okay, so my global secondary index is now created. And what I can do now is that if I go back into view items, I can look at my table and now I can query by game ID, game timestamp index. And so as we can see now, the partition key I can query by is my game ID and my sort key is my game timestamp. So this really shows you all the powers of indexes. I hope this makes sense and I will see you in the next lecture. So let's quickly talk about PartyQL for DynamoDB, which allows you to use a SQL-like syntax to manipulate DynamoDB tables. So this is what the statements would look like. And then from this, you can insert, for example, or update or select or delete items from a DynamoDB table. So it's to allow people who are more confident to use SQL to still be able to interact with DynamoDB. And it also supports batch operations if you need to. So let me show you how PartyQL works in the console. So I am in my tables, and on the left-hand side is the PartyQL editor. So let's open some of these tables. For example, let's open the users table, and I emptied it, but I can, for example, add an item real quick. So I can have a user ID 123, as well as a new attribute name Stefan, and this is good. And for my other table, the users post, I can again add some items. So user ID 123, post ID 456, and create the item. As well as for the demo indexes, I can create an item, user ID 123, game timestamp 2022, even if it's not really good, and then game ID 456. Okay, so I have created some items into all my tables. And now if you go to the PartyQL editor, we can look, for example, at the users table, and I can delete this, and I click on users and I do scan table. And it does a select star from users, which is a SQL statement. And if I run it, it says that the statement wasn't well formed. So now it is completed, and you can see that the items result is Stefan and user ID 123 that we can also get in a JSON view if you wanted to, because this is what will be used in your code to deal with it. And we can download the results to a CSV. Next, for more complicated stuff, you can look at the demo indexes table, and we can scan this table again. So we'll have the look at all the items, but you can do more interesting stuff. For example, you can query the table, and when you query the table, it generates for you a statement, and you say select star from demo indexes, where user ID equals, for example, 123. And then you can also have an end game timestamp equals sort key value, but this is optional. And if you run this, obviously, then we get the correct items. And so we can start building some pretty complicated queries, but because we have a index right here, we can actually use this index and scan it. So we can do select star from demo indexes and then the name of the index, and it's going to return the item based on my index. And you can do many things. You can run insert statements, although they're not easy to run directly from the UI because they're not automatically generated. You can also set an item, so you can update a specific item and set the attribute value, the partition key value, and the sort key value, and so on. Or you can, for example, drop a specific item and you have a delete from statement. So this editor is just for people who want to use SQL against DynamoDB, and I just wanted to show you the feature very briefly. Okay, that's it. I hope you liked it, and I will see you in the next lecture. So now let's talk about DynamoDB Accelerator, or DAX. DAX is a fully managed, highly available, and seamless in-memory cache for DynamoDB. The idea is that you're going to cache the most popular data, and therefore you're going to get microsecond latency for cached reads and queries. It doesn't require you to change any of your application logic. It's compatible with the existing DynamoDB APIs, and you just create a DAX cluster and you're good to go. Now, DAX, what does it solve? It solves the hot key problem. So if you're reading a very specific key or a very specific item too many times, then you may get throttling on your RCUs. But if it's cached by DAX, then you've just solved that problem. So let's have an example. We have a DynamoDB. It's made of tables, and our application is trying to access these tables. Now, in between, we're going to create a DAX cluster, which is made of cache nodes, and we have to provision them in advance. Now, the application will directly interact with the DAX cluster, and the DAX cluster will fetch the data from the DynamoDB tables. So by default, that means that some data is going to be cached. And if you think cache, you need to think TTL. So the TTL is going to be 5 minutes. So by default, every cached data will live for 5 minutes in your DAX cluster. Now, the DAX cluster is made of nodes, and so therefore you need to provision them, and you can have up to 10 nodes in the cluster. And it's a good idea to be in a multi-AZ kind of setup to have at least 3 nodes recommended in production, so 1 in each AZ. And DAX is fully secure, so you have encryption at rest, you have IAM authentication, VPC security, CloudTrail integration, and so on. So remember, DAX is here to help you cache the most popular items or queries from DynamoDB. Now, a question you may have is, what's the difference between DynamoDB Accelerator, so DAX, and Elasticache? Well, they can be used as a combination, and the exam may test you on figuring out if it's best to use DynamoDB DAX or if you want to use Elasticache. So with DAX, what you're going to do is that you're going to have a cache for individual objects or for your queries or your scans. This is very, very handy, and this is what I call simple types of queries. So your objects, your queries, and your scans. But if you're doing some kind of logic application wise, you're like doing a scan and then you're doing the sum and then you're filtering out some data and so on, and you don't want to do this every single time because this is computationally expensive, what you can do is you can store the results of whatever your application just did in Amazon Elasticache and retrieve the data from Elasticache directly instead of re-querying DAX and re-performing the aggregation client side. So this could be a good way to actually use them both together in architecture. Okay, so now let's go ahead and see how we can create a DAX cluster. So in the DynamoDB console, on the left-hand side, you have DAX. And DAX is not part of the free tier, so creating a DAX cluster is not going to be free. But you can just go ahead and see the process. So you create a cluster, for example, demo DAX, and then the node family. So which kind of nodes do you want to attribute into your DAX cluster? It could be T types or R types. So R is memory and T is for bursting. So this is recommended for use case requiring a lower throughput. And this is for always ready capacity, okay? Or you can compare all families. And in here, you can select the node types you want. So you want an R5 large, an R5 4X large, and so on. Or do you want to have a T2 small, and so on. So in this example, I'll take a T2 small. And then the cluster size. So do you want 1 up to actually 11 nodes? So they keep on increasing the capacity. 3 is going to give you a multi-AZ setup, right? But 1 is going to be good for example, just one AZ or for development. But if you have 1 or 2 nodes, you might experience reduced availability, okay? So let's go ahead with 1 node. I'm just going to go ahead and create this for you, but you don't have to go ahead because this will cost you some money. Now the subnet group is which subnet group do you want to associate it with? So demo subnet group. So this has to live within a specific subnet group and in a VPC. So you choose your VPC ID and then you choose the subnets you want to have. Obviously, 3 subnets means that you can have 3 nodes and be in a highly available setup. Access control. So what is a security group to access your DAX cluster? And you need to open up port 8111, okay, or 9111 if you do intrinsic encryption. So we need to go ahead and create a security group from the EC2 console, but right now I'll keep it simple and just use the default security group just to show you the process. And then AZ allocation, do you want to have automatic or do you want to spread your nodes manually? So we'll keep it as automatic. Next, for IAM permissions, so you need to provide an IAM service role that will give the DAX cluster access to DynamoDB. And so therefore, we are just going to create this IAM role called DAX to DynamoDB. And the policy will be created. We'll provide read-write capacity, rights, and we're going to give access to all tables, but we could obviously limit some tables if we needed to. Then we're going to encrypt data in transit and at rest on our DAX cluster, so this is good. And then for parameter groups, we're going to choose the existing one, so this one, and we could, on the left-hand side, define some more parameters thanks to parameters group. So this is going to basically tell how long to cache the items thanks to the time to live and what's the query time to live as well. So this is what settings you have as part of the parameter group. But by default, the one is giving you 5 minutes of TTL on both item time and query time. Okay. The maintenance window. So obviously DAX will be occasionally patched and upgraded. And so this is why it's good to have a multi-AZ kind of setup. And so you can say no preference or specify your time window, your tags, and then you're good to go. You can review it and create your cluster. So my DAX cluster is now created and let's have a look. So the important thing I want you to look at is here, there is a cluster endpoint, and this is the endpoint your applications should leverage to just leverage the DAX feature. Now we can have a look at the nodes. So we can have a look at the node types, how many vCPU per node, memory, and so on. So we can add nodes over time if we wanted to, but as you can see, we cannot change the node types, okay? And we need to create a new DAX cluster if you wanted to. We can have some monitoring, so we can do alarms and metrics around whether or not the cache is being used correctly. So cache hits, cache misses for items and queries, CPU utilization, and so on. So this is very, very handy to see if DAX is effective for you. Events to monitor the events of your database, as well as settings if you wanted to modify some settings such as the parameter group, network configuration, security configuration, maintenance window, and tags, okay? So that's it for DAX. I hope you liked it. Now I'm just going to delete this cluster, including all the CloudWatch alarms, and I will see you in the next lecture. So let's have a look at DynamoDB streams. So streams are an ordered list of item level modifications such as create, update, and delete that are happening within a table. So whenever you will insert an item or modify it or delete it, then that modification would be visible in the stream, and the stream will represent the list of all the modifications over time in your table. So stream records can be sent to multiple places, such as Kinesis data streams. So you can send a DynamoDB stream into Kinesis and then do whatever you want with it. You can also use a Lambda function to read directly from your DynamoDB streams, or you can use the Kinesis client library applications to read directly as well from a DynamoDB streams. The data retention within a DynamoDB stream is up to 24 hours, so you need to make sure to either persist it somewhere like Kinesis data stream, where you can have a longer retention, or use whatever Lambda or KCL application to persist it somewhere more durable. The use cases for using DynamoDB streams is to react to changes in real time happening in your DynamoDB tables. For example, having a flow to welcome you, to send a welcome email to your users, to do analytics, to transform the stream and create derivative tables in DynamoDB, or to send data into Elasticsearch for indexing and giving search capabilities on top of DynamoDB. Or if you wanted to implement global tables and cross-region replication, you would need to have streams in the first place. So if we look at the architecture of DynamoDB streams, so we have our application, which does create, update, and delete operations on our table. And any of these changes is going to appear in a DynamoDB stream. So from there, Kinesis data stream can be a receiver of your DynamoDB stream. And because we're using Kinesis data streams, then we can have Kinesis data firehose as a result, and then maybe send it to Amazon Redshift to perform some analytics queries on top of your data in DynamoDB, or sending to Amazon S3 for archival of all these changes in case we need to, or sending it to Amazon Elasticsearch, okay, to index it and to create a search capability on top of your DynamoDB table. The cool thing about this architecture is that it's pretty much everything is managed by AWS. If you wanted to add your own custom logic, you could use a processing layer in which you would create either a Kinesis client library app, maybe running on EC2, or a Lambda function that would be reading from DynamoDB streams. And from this, you can implement any sort of logic you want. So for example, you can have messaging or send notifications using Amazon SNS. You could do some filtering and transformation and then reinsert the data into a DynamoDB table. Or for example, you can also use Lambda to send data into Elasticsearch if you wanted to, okay? So this gives you a different kind of architectures and all the possibilities that open up by using DynamoDB streams. So if we consider the stream, then what do we have? In the stream, we have the ability to choose the information that will be appearing in it. So you can, for example, have only the keys, and it will just show you a list of all the key attributes that have been modified. New image, which represents the new item after it was modified. Old image, which represents the entire item, but as it appears before it was modified. And if you wanted to get the full information, you can get new and old images, which gives you both the new and the old image of the item, and therefore you can see which changes have happened. Now, DynamoDB streams are made of shards, just like Kinesis data streams, so they're very, very similar, and this is why the Kinesis client library works against both DynamoDB streams and Kinesis data streams. So the cool thing about DynamoDB streams, though, is that we don't have to provision any kind of shards. This is done automatically by AWS, so it is really a hands-off approach. Now, if you enable DynamoDB stream, just so you know, the records are not going to be retroactively populated in the stream after enabling it. Okay, this is an exam trick. So once you enable the stream, only then will you receive these updates based on the changes that are appearing in your DynamoDB table. Finally, let's have a look at how DynamoDB streams and Lambda work. So for this, we need to define an event source mapping to read from a DynamoDB stream. And then you need to ensure that the Lambda function has the appropriate permissions to pull from the DynamoDB stream. And then the Lambda function will be invoked synchronously. So let's take an example. The table goes into a DynamoDB stream. The Lambda function will have an event source mapping, which is an internal process that will be pulling the DynamoDB stream and retrieving records in batches from the DynamoDB stream. And when some records are passed on to the event source mapping, then the event source mapping will invoke your Lambda function synchronously with a batch of records from your DynamoDB stream. Okay? So that's it for this lecture. I hope you liked it, and I will see you in the next lecture for some hands-on. So let's get our users post table, and on it, we're going to enable DynamoDB streams. So to do so, let's go to exports and streams. And here we're going to have DynamoDB stream details, and we're going to enable it. Now we have the option to choose which type of view we want to have within our DynamoDB stream. And it can be key attributes, new image, old image, or new and old images. So I'm going to keep the last option to get as much information as possible, and I will enable the stream. Okay, great. So now my stream is enabled, and within it, as you can see, if I scroll down, there is the trigger. And the trigger is what is this stream going to trigger? So we can create a trigger, and here we have a Lambda function that can be invoked every time your DynamoDB stream is updated. So to do so, well, let's go ahead and create a new function, okay? And we can use a blueprint, and in here I can type DynamoDB, and we have DynamoDB process stream Python, which is going to log all the updates made to a table. So this is good. Let's configure it, and I'll call it lambda demo DynamoDB stream. Next, we're going to create a new role with basic Lambda permissions, and we'll make sure to edit this role to add the permissions to read from DynamoDB. Now for DynamoDB triggers, we need to create the trigger. So it's going to be the user's post. Which table was it? The user's post table, yes, indeed. And the batch size is 100. Okay, so this is how many records we'll read at a time. The batch window, if you wanted to gather records before invoking the function, so to be more efficient. And the starting position, so do you want to read from the start or from the end of the stream, just in case the stream had been already created. So we're good, we enable the trigger, and as you can see, what it does is that it just prints the records that we get out of the stream into the log, so we'll be able to view this in CloudWatch logs. So now we have created the function, but we get an error, which is that the function cannot access our stream because we have missing IAM permissions. So we're going to fix this. So we click on our function, and then under configuration, we're going to go under permissions, and this is the execution role. Now we have to click on this execution role, and we're going to add the necessary permissions to read from DynamoDB. So we'll attach a policy, and I will look for DynamoDB, and we'll have DynamoDB read-only access, because what we're doing is that we're actually, reading from DynamoDB. So this is good, and this one is also good to read from DynamoDB. So we'll attach these two just in case, but this is meant for Lambda, so probably a little bit better. So let's attach this policy. And to be honest, one of these is going to work. I'm trying to make this as simple as possible, which is why I'm not spending a lot of time on this. So let's refresh now this page. And it seems like we're good to go. So we have more actions on DynamoDB. So this is good, okay? And now if we refresh this, we can choose this function and set the batch size in 100, and we create this trigger. So now that means that my DynamoDB stream is going to trigger my Lambda function. And if I go back into my Lambda function and refresh this page, we can see that DynamoDB is indeed triggering my Lambda function. So this is an enabled type of integration with these settings. Okay, good. So next what I'm going to do is just test it out. So we're going to go to our table, and what I'm going to do is click on view items, and we're going to do a few things. For example, let's take this item, the second post of John. We're going to action, edit it, and then I'm going to modify. So I'm going to say second post here, edit, and click on save change. So this is good. And then we'll take Alice, and we're going to do action and then duplicates. So it's going to create a new thing, and I'm going to just add a bit more data. I say new Alice blog, and then create item. And then finally, we actually don't like this blog, so I'm going to delete it. So I'm going to do action and then delete items, and yes. Okay, so we've done three kind of operations. We've had an update, a create, and a delete. And so I went into my Lambda function. My Lambda function executed this code, which was printing, so logging these events. And so what I need to do is just go into CloudWatch logs and have a look at whether or not we saw these information in the logs. So let's click on view the logs in CloudWatch logs. And here we have some information around this log stream. And as you can see in this log stream, you get a lot of information. Okay, so we get one line. So this was a modify, and this was the DynamoDB record. So it gives you the key, the user ID, and as well as the new image, okay, and the content. So we can see, yes, a second post, yeah, edit. And we can also see the old image, so what it was before. So that was like for one request. Then we have an insert. And so again, we can see the DynamoDB record in it, and then the new image, and there's no old image because obviously it was an insert, so there was nothing before. And then we get a remove. And again, this remove operation was logged. We have the old image, and obviously there's no new image because the thing was removed, okay? So that's fairly easy. We just enable the stream, and it went to Lambda function, and the Lambda function was logging it. But this is the basis to have these kind of integrations with DynamoDB streams, okay? Lastly, please make sure to just disable the trigger. So on the DynamoDB, you take this trigger and you disable it or delete it, whatever you want, and you'll be good to go. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about time to live. And time to live allows you to automatically delete items after an expiry timestamp. So the idea is that you have a column you'll define, and then when you say the time of right now goes over the value of this column, then please remove the item. So having an item being deleted by a time to live constraint does not consume any WCU, so there's no extra cost. And this timestamp must be a number that represents the Unix epoch timestamp value, as we'll see in the hands-on. Now, expired items will not be expired right away. There is the guarantee that they will be expired within 48 hours of the expiration, okay? But in real life, it's actually pretty good. So if we look at a table, for example, a session data table that has two columns, user ID and session ID, we want to add an expired time, which is going to be the TTL of our table. And we're going to define when each session will expire. Now, what happens is that when you go and there is an expiration process in DynamoDB, it will look at the current time and say the current time is this, and it will scan the table and expire items that are going to obviously have a TTL epoch time less than the time right now. And then a second process will scan and delete these items from the table. And this is how TTL works. Now, these expired items that haven't been deleted will still appear in the reads, query, and scan. So if you don't want them, you need to do some client-side filtering. So there could be some expired items already in your queries. You need to wait at up to 40 hours to see it being deleted. And when the items are deleted, they're also deleted from your indexes, so your local secondary indexes and your global secondary indexes. And a delete operation for each expired item enters the DynamoDB stream. That means that any item that gets deleted thanks to the TTL will be in that stream, and you could recover it if you wanted to. Now, the use cases for TTL would be to reduce stored data by keeping only current items, to adhere to regulatory obligations, or for example, for the session data, it is a perfect use case of TTL. Okay, so let's have a look at how we can define a TTL in DynamoDB. So let's go ahead and create a table, and I'll call this one demo TTL. Now the partition key is going to be user ID, and we don't need a sort key right now. Okay, we'll customize the settings. We'll set provisions and autoscaling off. We'll have one RCU and one WCU, and then we'll go ahead and create this table. So my table is now created, and what I'm going to do is just add a little bit of data. So I'm going to insert some items. So I'm going to create an item. User ID is John123, and then I'm going to add an attribute. For example, name is going to be John, and then I want to have an expire on attribute. So expire on, and it's not a string, it's going to be a number. So we do expire on, and then we need to give an expiration date to John. So I call it epoch converter online, and let's just get the first one. And so this is how we can translate a timestamp of soon into an epoch timestamp, which I can enter into DynamoDB. So for example, if I take, say, 5 minutes from now, so here we go, and I do human to timestamp, here is the epoch value of 5 minutes from now. So I'm going to paste that in and click on create item. So that's one item that's been created, and I will create a second item, and this one is Alice 456 as a user ID, while Alice's name is going to be Alice, and we need to again have an expire on, and the expire on we can say, for example, 1 hour from now. So we'll have 10 here and click on human date to timestamp, take this in and paste it and create item. So now we have 2 rows in our DynamoDB table, okay? And both of them have a different expire on attribute. Now we need to go ahead and define the TTL on our table. So if we look at our table, we can see the time to live is currently disabled. So what I can do is go to additional settings, scroll down, and then look for the time to live and click on enable. Now we need to give the TTL attribute name. So what is the data that I want to expire, the column I want to expire on? So expire on is the name that I give to this TTL attribute name. And then we could run a preview, okay? So if we run a preview right now, it says that these 2 items will be deleted in 1 hour. So if we take, for example, the time right now, which is right here, and I do run preview, it says, hey, there's no items that I want to delete, right? But if we do 1 hour from now, so if we do, for example, 10, 10, 10, and I get this epoch timestamp right here, and paste it, run preview, only John will be expired, okay? And then if I go a bit after, so if I go to 1050, and take a human timestamp, date to timestamp, and paste this in, run a preview. Now 2 items will be deleted. And you could either specify an epoch value or a custom time, or in the next 60 minutes, 24 hours, or 7 days, which is quite cool for running some simulations. So we can enable TTL, and now TTL is enabled, and automatically, if I wait for 1 hour, my items are going to be completely expired, okay? So this is pretty cool, and we can view a graph of all the items deleted in the last 24 hours, thanks to this feature right here, okay? So this is a CloudWatch metric. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's look at 2 ways we can use DynamoDB with Amazon S3. And the first one is how to store large objects in DynamoDB. Well, it turns out that, as you know, in your tables in DynamoDB, you can only store up to 400 kilobytes of data. So obviously, if you want to start storing some images, some videos, all that kind of stuff, DynamoDB is not the best place for it. So instead, what we're going to do is that we're going to have an Amazon S3 bucket that will contain our large objects. So what is the process to upload a large object? Well, say we upload an image into Amazon S3, we're going to get back objects key. And what we're going to do is that we're going to store this metadata from the application into the DynamoDB. So we'll have a product ID, a product name, and then an image URL, which is a pointer directly into Amazon S3. Now, what we've done is that we've effectively stored a very small amount of data in our products table in DynamoDB, and we stored the large item in Amazon S3. Now, from a reading perspective, a client who wants to read this data first gets the metadata from DynamoDB, and then we'll get the image back from Amazon S3 to reconstruct these large objects. So we can go on and have many different products and use the strategy at scale. And the cool thing about this strategy is that we're using each service for what it's good at. So Amazon S3 is great for storing large objects, okay? And DynamoDB is great for storing small objects that are going to be indexed with specific attributes. So in this example, we have the perfect combination of Amazon S3 and DynamoDB. Another combination or synergy we can have is to use DynamoDB as a way to index S3 objects metadata. So the application is going to upload objects into Amazon S3, and Amazon S3 will have notifications set up, for example, to invoke a Lambda function. That Lambda function will store the object's metadata into DynamoDB table, for example, object size, date, who created it, whatever you want to think of about these objects. And why do we do this? Well, because it's much easier for us to build some queries on top of the DynamoDB table than on top of an S3 bucket. Again, an S3 bucket is not meant to be really scanned. It's meant to store large objects, and you're supposed to have some sort of database that knows what these objects are, their attributes, and so on. So by creating an application on top of DynamoDB, we can answer some questions such as, hey, we want to find objects by a specific timestamp on our S3 bucket, or we want to find the total storage used by a customer, or list all the object with certain attributes, or find all the S3 objects uploaded within a date range. All of this by querying DynamoDB table, and then we read back the results from the DynamoDB, and we retrieve the necessary objects from your S3 buckets, okay? So hopefully these 2 strategies make sense. They're quite common, and they can come up at the exam. I hope you liked it, and I will see you in the next lecture.
So now let's talk about DynamoDB security. Basically, you have VPC endpoints to access DynamoDB without the internet. You can get access fully controlled by IAM. You can get encryption at rest using KMS, encryption in transit using SSL and TLS. So it's basically as secure as any AWS service. You get backup and restore feature available. So you can do a point-in-time restore just like RDS. There's no performance impact when you do backup and restores. You can define global tables, which are multi-region, fully replicated, high-performance tables. And you can use DMS that we saw before to migrate data to DynamoDB, for example, from MongoDB, Oracle, MySQL, S3, etc. We can also launch a local DynamoDB database on our computer if we need to do development or just test a few things out. Okay, so that's it for DynamoDB. I hope that was helpful. I hope that was a well-rounded introduction to it, but should be enough for your big data exam. All right, I will see you in the next lecture.
So for our next hands-on activity, we're going to continue to build out our order history app. This time we're going to introduce DynamoDB into the mix and illustrate some of the stuff that we've learned so far. And for now, we're not going to use AWS Lambda because we haven't covered that yet. Instead, we're going to use a custom consumer script that will just sit on our EC2 instance, listening for new data on our data stream that we created earlier and funneling that into an Amazon DynamoDB table. Later on in the course, when we cover Lambda, we'll fill out that piece as well. We're just getting there one step at a time. So for now, let's build our Amazon DynamoDB table and create a consumer script to fill the gap between the data stream and DynamoDB. So first thing we need to do is go to our AWS Management Console. I've already logged into mine here, and select DynamoDB. Type it in here if you don't see it in your list. And we're going to create a table. We're going to call it Cadabra Orders. Again, pay attention to capitalization and spelling. Our partition key is going to be customer ID, spelled just like that, and that is a number. The reason being that our order application is meant for an individual customer to look up his or her order history. So it makes sense to partition our data by that customer ID so DynamoDB can very quickly retrieve the information for a given customer as a whole. We'll also add a sort key because customer ID isn't unique enough for us, right? You know, there could be multiple records associated with a given customer ID representing individual items that they've ordered. So the partition key by itself is not sufficient to provide a unique key. So instead we'll add an order ID as well that represents an actual line item order ID. And we're going to have to fabricate that, as you'll see shortly. That will remain as a string. We can keep all the provisioning set to the default settings. We are within the free tier of usage here for DynamoDB. You are allowed way more data and way more capacity than we're going to use right now. So as long as your account is relatively new, don't worry about being billed for this. Hit create, and we just have to wait for that table to be created. Meanwhile, let's set up our consumer script. So let's log into our EC2 instance, however you might do that on your system. I will log in as EC2-user. So the first thing we need to do is install the Bodo 3 library, which is basically the AWS API that we're going to use on EC2 for Python. And right now on EC2, things are in kind of this weird state. So the Amazon Linux 2 AMI right now is still using Python 2.7. If we say which Python, you can see that Python is pointing to user bin Python. And if we were to say Python-big V, we can see we're on Python 2.7. However, AWS is actively deprecating Python 2.7 right now, so we don't want to use that. And as of this recording, in June of 2021 at least, Python 3 is installed alongside Python 2.7. So if you say which Python 3, you can see that Python 3 is available to you there, but you just have to use Python 3 instead of Python, so keep that in mind. Similarly, to install packages, we're not going to use pip, we're going to use pip3. Actually, there is no pip installed by default anymore, but there is a pip3. So what we're going to do to install Bodo 3 is just say pip3 install Bodo 3, just like that. And I've already done this, so for me it's not going to do anything, but for you it will go out and download it and install it. So now that we have the packages we need, we can move on. We also need to create some credentials files. This is so Bodo 3 knows how to log into AWS using your account credentials and also what region it will be in. First step is to create a .aws folder in your home directory. Let's make sure we're there first. So let's go ahead and say makedir .aws. We'll cd into it and create a file called credentials in there. So nano credentials. And in here, we're going to type in square brackets default, AWS underscore access underscore key underscore ID equals whatever your access key is for the IAM user that you created earlier in the course. If you don't have that handy, you can copy it out of the credentials that you put in for the agent.json configuration file for Kinesis. Or you can always create a new IAM user for this worst case scenario. I scrolled away a copy of it here, so I'm just going to copy that in here with a right click that I copied it from. And the next line will be your secret key. That will be AWS underscore secret underscore access underscore key equals whatever your secret access key is. And again, don't get any cute ideas about using my credentials because they are not going to exist by the time you see this video. Go ahead and hit Control O to write that out, Enter, and Control X. We also need a file called config in here, so let's say nano config. Again, we'll do in square brackets default. And we will type in region equals whatever region you're setting up your services in. For me, that is US-East-1. All right, Control O, return, Control X. All right, let's cd back up to our home directory. There we are. And let's download our actual consumer script. So wget http://media.sundog-soft.com/AWS big data consumer.py. Pay close attention to spelling and capitalization. They both matter. All right, so our script got downloaded successfully. Let's take a quick look at it and see what it does. Nano consumer.py. And you can see we're importing that Bodo3 library that we just installed. And we are creating a client for Kinesis that is connected to the Cadabra orders Kinesis stream that we created earlier in the course. And we're creating a client for DynamoDB that's tied to the new Cadabra orders table that we also just created. Then we just sit here in this endless loop until we actually break out of this application. And it just sits there waiting for new records to come in from Kinesis, from our Cadabra order stream. And if it finds a new record, it parses out all the information. As you might recall, our Kinesis agent actually converted all of our source data from CSV to JSON for us. So we just have to parse out that JSON data here. It will print out each record just so that we can see its progress and select out the data, invoice, customer, order date, etc., based on the fields in that JSON record that it received from the Kinesis stream. We're also going to construct a unique sort key for this line item. There's no actual order ID that's unique to each line item in this data set, so we have to make one up. And to do that, I'm going to fabricate one by just concatenating the invoice number and the stock code. The idea being that you're not going to have more than one line for a single stock code on a given invoice, so this should suffice for creating a unique sort key for every item of data here for us. After that, we call table.putItem to actually insert this data into DynamoDB. And that's pretty much it. It just sits there and sits in an endless loop, waiting 1 second between each one so we don't hit any capacity issues on timeouts. Pretty straightforward stuff, right? So let's go ahead and hit Control X to get out of this and see if it works. First, we have to make this script executable. So change mod a plus x consumer.py. And now we can just run it. So /consumer.py. And now it's just sitting there waiting for new data on my Kinesis stream. So let's give it some data to play with and see what happens, shall we? I'm going to right-click on PuTTY and open up another terminal window to my EC2 instance. We'll put them side by side here so you can see them both together. We'll log in again as EC2 user. And let's go ahead and run sudo ./loggenerator.py10. That will insert 10 rows of new data into our log files, and the Kinesis agent should pick that up. And in turn, our consumer script should pick that up and put them into DynamoDB. So let's kick that off and see what happens. It will take about a minute for the agent to catch up with things and notice that that new data exists and process it. So let's just be patient for a bit here and see what happens. We're watching the leftmost window here to see if the consumer script actually picks up that data and does something with it. All right, looks like something happened there. That's pretty cool. So apparently our script did pick up that data, and I don't see any errors, so that's a good sign, right? So let's check out our DynamoDB table and see if we have any shiny new data in there that it actually put in. Let's go back to our AWS console here, and we're still in the screen here for our Cadabra orders table. If we click on items, there it is. That's pretty cool, huh? All right, so there's 10 rows of data, right? Yep, looks about right, and looks like it all came through in one piece. There's our primary key of customer ID coming in, our sort key of order ID. Together, these provide a unique key for each row. And it looks like the rest of the data came in successfully. We have valid-looking countries, descriptions, order dates, quantities, and unit prices. So cool, it all worked. We have actually created a system that works from end to end, where we actually monitor new information being output into a log directory on an EC2 host. A Kinesis stream picks that data up. We then have a consumer agent that's actually running on another EC2, or in this case, the same EC2 instance, that then turns around and inserts that into DynamoDB. And you can imagine a mobile app that could talk directly to this DynamoDB table to return order information for a specific customer very quickly. So we actually have something here that works from end to end. Like I said, later on we'll come back and replace that consumer script with an actual Lambda function, which will be even more scalable. But congratulations. Built something real here. That's pretty cool.
So to be honest, Elastic Cache does not come up very often in the exam, but I'm still going to introduce it to you just so you know what it is. Well, in the same way you use RDS to get a managed relational database, use Elastic Cache to get a managed Redis or Memcache. And they're basically caching technologies. They're in-memory databases and they have really high performance, really low latency, basically to cache objects. That helps you reduce the load off of your database when you have read-intensive workloads. It helps you make your application stateless. And you even have write scaling using sharding, read scaling using read replicas. multi-AZ for failover capability, and AWS will take care of all the OS maintenance, patching, optimization, setup, configuration, monitoring, failure recovery, and backups. Basically, this is RDS but for caches. So we have two caches technology. You don't need to remember them too much, but just as a high level, it's fine. There's Redis and Memcached. So Redis is an in-memory key value store, has super low latency, sub-millisecond, and the cache will survive reboots by default. It's called persistence. So your cache is persistent. It's great when you have user sessions, leaderboard, distributed states, when you want to relieve pressure on your databases, such as RDS, when you have to have pub/sub for messaging. Redis is going to be a great use case for that. You can also enable multi-AZ with automated failover, I already told you this, for disaster recovery, in case you don't want to lose your cache data. There's also support for read replica, so this really scales well. And Memcached, it's another technology. It's more used for objects like S3, so the cache doesn't survive reboots this time, so the use case would be a quick retrieval of objects from memory when the cache is often accessed. Overall, I would think that Redis now has an overlapping feature set over Memcached, and it's more popular. So if you need any caching, I would strongly recommend Redis instead of Memcached. So that's all you need to know going into the exam. Some very architectural aspects about Elasticache, and that's why I'm pretty brief on it and I don't do any hands-on. But you get the idea. It's an in-memory cache, high performance, good for caching database writes or reads, that kind of stuff. All right. I will see you in the next lecture.